One, two, one, two, one, two.
2, 3. 1, 2, 3.
Okay, so that means we were out late last night, I understand. All right, well, we have to do some jumping jacks and a little bit of breathing exercises to wake up a bit more. No? Okay.
Okay.
I hope everybody enjoyed yesterday. We had some great presentations. I know we got some great presentations lined up for us today as well. I just want to do a couple of housekeeping things here real quick.
I can use
Number one,
I can use that one.
please make sure you silence your mobile so that we don't have a symphony going off in the audience at times. That would be great for your fellow delegates and for the speakers. The other big thing that I'd like to just remind everybody about, tomorrow we have two really excellent training events going on. Ricardo Tani will be doing his offset training. I have attended this personally in the past. This is an awesome class. If you want to learn about how to have better offset on the internet for investigations, research, things along those lines, this is a great class to attend. Ricardo's coming all the way down here to do that presentation. I encourage folks to show up. In addition, tomorrow we will be doing a training on RPKI. So if you want to learn more about RPKI, we had some conversations about that yesterday in presentations and what have. So tomorrow we also have a great, excellent RPKI presentation going on. So that's all the housekeeping stuff. Without further ado, I'd like to introduce Mike Holmberg, who is going to talk to us about 5G transport, data center fabrics, and exciting technologies. So let me try to get his presentation up here. And let's see. It's a Windows machine. I'm not a Windows guy. Where is this? Is a PDF? Okay.
It's a PowerPoint.
It's a PowerPoint?
Yeah.
So just have to put it on one screen.
That's the PDF into PowerPoint.
This is the one. Just put it on.
I love packets, so. There's also a PowerPoint.
Some challenges.
Yeah, there's a PowerPoint version of that too.
This is a PowerPoint. Should be a PowerPoint.
I think he brought it up as a PDF.
It was just a build on that.
Ta-da! And we have victory. Michael, thank you.
Thank you. All right, good morning. So I had the pleasure of being the first here today this morning. As I was introduced, my name is Michael Holmberg and I'm coming from Extreme Networks. So I'm going to talk about a topic that might be a bit outside of what you guys usually hear on this event, which is obviously covering things like BGP, RPKI, things like that. I'm going to touch on 5G. So now you might wonder, so why is a guy representing an Ethernet switch router vendor talking about 5G? So reason being is that I'm going to touch on the transport part for 5G. And I hope that you basically, after my 30 minutes presentation, get the context why actually somebody representing an Ethernet vendor is talking about 5G and transport in particular. So to set the ground, 5G is much more than just basically radio and core. 5G is things like automation, orchestration, management, virtualization, software-defined infrastructure, and transport. So my thought was to basically, set the stage here for my talk, to kind of start with a recap of 4G and then look at 5G. And I'm doing this in the context of truly transport part. I'm ignoring everything else. I'm just, kind of touching on the transport part. Due to the fact that, 5G is truly driving network changes. And with network, I mean basically going into something called the X-haul networks. Being the legacy, backhaul going into now front haul, mid haul, and backhaul. But if we basically start to, look at this from 4G and then kind of comparing that to 5G going forward. So 4G was one key service, one shared transport network. And that shared transport network was basically just backhaul point-to-point connectivity provided by carrier Ethernet. Totally fine. Consumer focused, you had best effort traffic, latency is not critical. And then, you had some statistical SLA for backhaul transport. And you had basically, or have basically, a simple RAN architecture. Now, if you look at 5G, first of all, one key thing with 5G, it's a service-driven architecture, which basically means that you talk about 4 predefined services. You had a RAN 5G core, you have the hyperscalers, as well as transport. And then you go into things like, network isolation, slicing, which basically means that you are going to have the same network, or the same network is going to provide transport for multiple different use cases. So now you start to talk about things like different requirements within the network. So truly, going from best effort to critical data, which basically means that you might have, bandwidth-hungry applications like fixed wireless access, or you might have something that is truly, latency dependent. Many of you have probably heard about the, kind of famous 5G killer application being the autonomous driving, which basically, as you understand, means that you need to have truly low latency. So that gets you into things like how would you cope with latency, QoS, all those different things. And then from previous 4G, you go into 5G, where you basically have then, the multi-destination, multi-point connectivity, dynamic connectivity requirements. So that actually dictates more or less that you start to move now from a layer 2 environment into a layer 3 environment. And then you go into something like the CU to CU. So sorry, there's a lot of acronyms here, but in short, it basically means that you start to talk about, domain-driven things, like the example I gave you on autonomous driving. We all understand that latency is a key, attribute. You can't cope with much latency. Hence, you are going to have traffic, residing within an area, so more a domain in that sense. And then you get into the other acronym being MEC, which is obviously edge or the multi-access edge, mobile edge cloud, whatever you basically want to kind of use for that acronym. And as mentioned, routing is required. And then to add more complexity, you go into multiple RAN architectures. And to add on, you start to look at virtualization. So virtualizing the core, the control and the user plane. So I guess you kind of realize that with more or less this introduction, 5G is putting a lot of new demands on transport networks. So I want to touch on this slide just briefly, but basically Where I want to get with this one is saying that, as said, you have different RAN architectures. So you have the distributed RAN, which is more like the legacy 4G. This is still going to be applicable for 5G going forward. Then we are going to introduce something called the centralized RAN, or the C-RAN, which is basically an architecture in which the base station is split into two parts. You have your radio head and baseband unit. Taking this now further basically means that you talk about virtualized RAN, which basically is that means that you are going to virtualize all your RAN functions. So think of this in a nutshell, that instead of having purpose-built hardware for your radio functions, I'm going to move those radio functions onto running on computes within a data center. So you are basically going to have a complete kind of virtualization of all those functions running on computes. And then you might have heard of the Open RAN, O-RAN. O-RAN is not an architecture per se. It's more like a way of defining a disaggregated model where you basically have multiple different vendors, equipment, software, subsystems, so on and so forth, defined within open interfaces and things like that. So with that said, I'm basically now going to touch more on this virtualized RAN, the vRAN part. So is your network truly prepared for the evolution to 5G? As you can see in the slide here in the middle, you basically have an itself, basically, where latency is becoming truly a critical factor. And then you go into massive, machine-to-machine communication, like Industry 4.0, where you basically have a lot of sensors, things like that, where security might become the challenge, how to basically, be able to realize that. So PTP, I guess majority of you guys heard about PTP. I guess many of you might have deployed it already. But PTP in a nutshell, it's a protocol for distributing precise time and frequency over packet networks. It's an IEEE standard, and you basically had the first version ratified back in 2002, which was targeting LAN applications. The second version back in 2008 was expanded to basically cover the telecom networks, and there is a third version now under discussion as well. So for PTP, time is carried in an event message, which is transmitted from a grandmaster clock into a slave clock, which basically means that I have a way of putting a timestamp on my Ethernet packets across the path from my grandmaster all the way to the base station or my radio. It runs over Ethernet and IP networks, and you basically have also an acronym TSN, which is time-sensitive networking. Under this 802.1q umbrella, you basically have the CM part, which is more looking at it from a telecom side, and then you have the BA part, which is more looking at this from an AVB, as well as obviously the aerospace, industry utility, all those different things having a bit different requirements from a timing perspective than in the telco part. And then you have some other, like radio Ethernet, which is a way of transporting the TDM-based CP traffic as blended traffic over an Ethernet connection together with Ethernet. I'm not going to dig into more details on this. This is just kind of an overall, just statement that this is obviously what the TSN is defined as. So to put this into some context, you also have PTP profiles, and in the first version you had a telecom profile for frequency defined as the G8265.1, which was published back in 2010. And the main idea with that profile was to support frequency synchronization over telecom networks. And to basically define what the profile is, it contains a defined combination of options and attributes and values defined within a profile for specific use cases in that sense. To basically we'll fast forward here and look at the current kind of from a 5G point of view, you have two new profiles. You had the G8275.1, which is the full timing support, and you had the G8275.2, which is a partial timing support. In a nutshell, the difference between these two are that the full timing support requires each and every device within your network to be a PTP boundary clock. So PTP have, things like boundary clock, transparent clock, and transparent breaches. It's just the way of how you would then basically regenerate your frequency more or less. But in a nutshell, to understand the difference, so full timing support demands each and every device within your PTP domain to actually support PTP boundary clocks, which obviously is or means you need to have a greenfield install for that. While the partial or the G8275.2 partial timing support allows you to have either boundary or transparent clock or even transparent breaches within your domain, PTP domain. And to translate that into a more kind of understandable lingo means that not each and every device within that PTP domain need to be PTP understanding. However, having said that, if you look at the last bullet point, you do have a predefined target accuracy of 1.5 microseconds between any grandmaster and your end station. This is, the magic figure you need to work with. So I'm going to skip over this in the interest of time. You guys have this as reference material. And get to this one. So this is basically, just an illustration of your PTP domain as such. So what you'll have on this one is your GNSS satellite providing you the time. You might have, multiple of those for redundancy. Then you have your grandmaster clock, which is basically responsible for picking the time for your GNSS satellite, put it into a packet, and transport it further on over your network. So this is your grandmaster clock, which is basically your reference, your PRTC reference clock here, which basically means that each and every path within your network, going from your grandmaster to the base station or your radios, needs to be PTP enabled, needs to understand PTP. So, as I mentioned, you had 1.5 microseconds as the magic figure here between any, radio and your grandmaster clock here. And then obviously now you see you have a 3 microsecond, but the 3 microsecond is between any two, RUs. And this is a relative measurement. So this is truly, what is defined. So you talk about something like the TAE, which is a timing alignment error. And obviously you need to basically, obey to that one. There's a bunch of other things here, but in the interest of time, I'm going to skip over these and just get into, the key factors and how would you measure this within your network? Because I guess you guys at a given time are starting to look at how would you transport 5G traffic within your infrastructure? How would you provide some kind of a path for that? So you get into discussing or looking at, the factors that make a poor synchronization. You talk about two things. You have the CTE and the DTE. You have your latency asymmetry and your latency variation. Now, maintaining synchronization quality is basically maintaining your latency. And the right-hand side, you basically have an illustration of PTP. So it's basically the PTP event message flow, which defines the packet time, which is more or less the packet timing signaling, where you basically have the master frequency is more or less then obtained by having the timestamp T1 and T2 together with your sync and sync ACK messages T3 and T4. This is how you would then basically synchronize your slave clocks to your master clock. Sorry for that, there was supposed to be a build on this, but anyways, let's cover this from the bottom up. So the first part is then when you start to measure this and make sure that your network is truly, prepared for 5G transport. As said, is, being able to measure your timing alignment error. And you have multiple different kind of aspects within your network. You obviously have the fixed network itself as well as the over air. But on the right hand side you see the max TE, timing alignment error, 1.5 microseconds. That is end to end, as I alluded to earlier on. But then you see the kind of the orange arrow as well, which basically defines the max TE being 1.1 microseconds. And this is over the network, over the wired infrastructure. Which basically means if you look at the left-hand side of the slide, you basically see that, okay, so the first part is that you're going to take your time from your PRTC, basically introducing your timestamp into packets on the grandmaster clock. Then you're going to introduce some kind of alignment error, as we can see 35 nanoseconds here. Then you go into your DTE and the CTE part, one being the dynamic, one being the constant. The constant is basically your network elements. And what is a network element? It's a switch, it's a router. And there you have different classes, A, B, and C, which basically defines what is, the timing element, the timing error that you are going to induce by implementing such a node within your network. So that would dictate how many nodes you can actually have in your network. So as we can see here, you have a type A being 50 nanoseconds, type B being 20 nanoseconds. In addition to that, you are going to add on your link asymmetry delays, which is basically your link delays, latency. And there we can see you once again have, depending on the type of the node, different values. So all in all, 1.1 microseconds is the network-wide timing alignment error that you can cope with. And then you add in, the end application noise and some rearrangements of short-term holdover, things like that, which is RF over air. And this brings you to the total value of 1.5 microseconds. So on that note, this was a pretty fast walkthrough, touching on the transport part for 5G. Might be a lot of abstract things for you guys, but I think, the key thing is to understand that 5G is putting a lot of new requirements on your network infrastructure going forward. Any questions? Did you follow me on my presentation?
All right, well, anybody else, any questions or any comments, follow-ups? Please announce your name and company.
Thanks, morning. I'm Kim from ZANOG23. We are the Wi-Fi sponsor for the event, so I don't think there have been any issues. And I also just want to let you know that we are a distributor for streaming groups. So between Michaela and I, if you want some more information, please reach out and I will be around.
Thank you.
Great, thank you, Michael.
All right, thank you.
All right, so I think up next is Mark.
Let me put your mic.
Mark's going to talk to us about spatial division multiplexing, the new subsea cable paradigm. Thanks, Mark. I know I butchered your last name. Sorry about that.
Get it all the time. All right. Morning, everyone. I'll be talking about submarine cable systems, in particular, where we're going with them as we try to expand capacity in the networks around the world. And most of that has been driven by the growth in internet traffic carried by submarine cables over the past couple of years. I think now we're seeing about 1.5 petabits per year, actually, as of 2023, and we expect that to double in the next 5 or 7 years. Looking at the evolution technologically, we've obviously come from simple modulation schemes all the way up to WDM, and now we're looking at SDM, which is the purpose of this talk. SDM, which is not unlike existing terrestrial infrastructure, is underpinned by what is known as coherent technology. Prior to coherent, we had direct detection, and direct detection is what allowed cable systems, terrestrial and submarine, to support 2.5 gig as well as 10 gig wavelengths. With coherent, we add the possibility now of supporting both phase and amplitude, and because of that, we can scale the infrastructure up to anywhere between 100 gig to 800 gig waves per fiber pair. But in coherent also comes a lot of other features and capabilities that allow us to even support this kind of capability and capacity in all the cable systems as well that were mostly built for direct detection. So if you look at the last 8 to 10 years, we've jumped just about 8 times in coherent capacity, from 100 gig back in 2010 at about 40 nanometer CMOS, and now we're at 800 gig with about 7 nanometer CMOS. And that's sort of where we are at the moment. The magic of coherent lies in the DSP within the line card or the transponder. So you find a lot of the vendors will have a number of features and tricks to extract the most out of compensated or uncompensated cables, like higher baud rates, PCS, bandwidth virtualization, framing, and all sorts of things. And that is really to extract the most out of the signal as a function of noise. Just to sidestep a little, ADVA, in collaboration with Coherent Corp, developed an optic in the ZR space for 100 gig. This is a tunable optic. There's no price yet for it, but it should be launching within the next, I'd say, year and a half. It's in beta at the moment. And this allows us now to provide coherent technology in the metro for up to 100 plus, excuse me, up to 100 plus kilometers on a QSFP28 interface. So it is a vendor neutral optic. It is the first of its kind in this space, and it should be quite exciting for us to extend 100 gig beyond 40 kilometers, for example, safely. But this is the kind of power we can expect to see out of coherent technologies at least on the terrestrial side. One of the ways that we've been able to increase capacity on subsea and also on terrestrial is by moving from fixed grid to flex grids. With fixed grids, you have a standard 50 gigahertz bandwidth channel into which you need to run your wavelengths. And that can be a bit wasteful if you don't need to run the entire channel, or if you need to be more specific about the kinds of services you want to offer. So with FlexGrid, we can take full advantage of the continuous 4.8 terahertz block of spectrum in the C-band, and we can break that up into chunks of 12.5 gigahertz or even 6 gigahertz, and have different services running at different wavelengths, different capacities for different customers, different services, and that allows us to extract even more capacity out of the WDM system. And submarine cables, especially SDN, take advantage of this, particularly if you're trying to solve for non-full fiber pair purchases on the cable system. You can use this technology. Anyone familiar with Shannon's limit? Sort of, yeah. Yeah, okay. Because uncompensated cables today do not require dispersion management, you are now able to, I think we've just about reached the limits of coherent technology as how much capacity we can extract out of a cable system, or out of a fiber pair for that matter. And because of that, we're getting close to Shannon's limit in that for a given amount of spectrum, there's only so much capacity we can run through it before we start hitting nonlinear inefficiencies. So because of that, we're now moving back to old school and fixing the problem with physical infrastructure and not mathematics. So with SDM, we're now fixing the problem with actual physical fiber, as opposed to trying to find new ways to do more math in the chipsets. So this is how we sort of sidestep that limit in SDM. On the first side, you'll see there's dispersion managed cables, which would typically were installed between 2000 and 2010. So think of the first transatlantic cables. Those were dispersion managed. Those are the ones that we couldn't get to more than a 10 gigabit wavelength because we had to have physical dispersion management within the cable span itself. And then from 2014 to about 2020, we now support uncompensated fiber cables, meaning that they have a high surface area in the core. They are low attenuation, low latency, and they're highly dispersed, which means that they are ideal for coherent, because coherent performs really well in cables that are high dispersion, positive dispersion. So then we have SDM from 2020 onwards. And the main thing with SDM is the biggest limitation you have in submarine cable systems, which is power. Okay, so unlike terrestrial cable systems where you have power at every amplification site, meaning that you have a lot of options with capacity expansion, in cable systems, submarine cable systems, you only get power at either end of the cable. You don't have power along the repeaters under the sea. So because of that, that really governs how much capacity you can have on the cable system. And the idea with SDM is that we manipulate the amount of power available to determine how much capacity we can run in the system. With uncompensated cable systems, for example, such as these, you had So with SDM cables such as these, for example, you can have as many as 24 fiber pairs within a cable, which means that you don't need to have as many amplifiers, or you can space the amplifiers a lot further apart, and if you space them further apart, then you can get away with using less power for the entire system. And if you use less power, then you sacrifice a bit of efficiencies in the spectrum, but then you compensate for that by having more fiber pairs. So you lose capacity per fiber pair, but because you have more fiber pairs, you actually have overall more capacity in the system. So this is really an illustration, of those advantages. Because you have longer amplifier spacing, you just require much lower power to launch the signal. And because of that, then you don't suffer as many nonlinear impacts as you would if you were using significantly more power. And also one other thing that's come up recently is that you can share pumps within the amplification system. All the cable systems had a 1+1 backup for pumps, which means you use more power. So sharing pumps in the cable system doesn't necessarily give you more capacity, but it allows you to have more playroom with energy, with power. Because the fewer pumps you have, the less energy that you need. So in the end, you end up with a higher fiber count, but lower capacity per fiber pair, which still gives you more capacity. So in uncompensated fibers, such as these, for example, it's typically anywhere from 2 to 8 fiber pairs, again limited by power, so you can't have more fiber pairs than that because you're limited by power. It's high amplification, so a lot of spectral efficiency, but because of that, then again, you can't have too many fiber pairs. And you're looking at an average anywhere from 32 to 192 terabits per system if you're looking at as high as 8 fiber pairs, which seems like a lot. But then when you move on to SDM-based cables, you now have the ability to reduce the power that you use because you want to be able to carry more fiber pairs. So if you use less power over the entire system, you can have even more fiber pairs, 24 in this case. I think a cable like Medusa has 24 fiber pairs. And because you're sacrificing that kind of efficiency and compensating for it by having more fiber pairs, you can have almost half a petabit of capacity on the system. If you look at evolution, for example, that explains where the fiber pairs have come from since the 2000s. So all these are about 6,500 kilometers transatlantic cables. Apollo went in 2003 with 4 fiber pairs. This was a dispersion managed fiber system, originally with a per fiber pair capacity of 10 gig. But then now with coherent technology, we've been able to upgrade that to about 10 to 11 terabits per fiber pair, which means a total capacity of 40 terabits for the 4 fiber pairs in the system. And this is just using coherent detection on a dispersion managed fiber system. For Maria, which is also transatlantic, 6.5K distance as well, uncompensated fiber pair, which means that it has a much wider surface area. It also is positively dispersed, but with 8 fiber pairs using coherent technology, we can extract up to 26.2 terabits per fiber pair on that system for a total of close to 210 terabits for the entire cable system. So then you come into the SDM, which is Danant was the first one that Google deployed in 21, also transatlantic with 12 fiber pairs. You can see the capacity goes down a little bit to 25.2, but because there's more fibers in the system, you end up with 312 plus terabits. Same for the Meta cable, which is currently being built as we know. So this is just an evolution, for example, that shows you how when we make advances in power management with the cables and with coherent as well as with the type of fiber, we can then increase the capacity of the cable system even if we are reducing the per fiber pair capacity. Some of the benefits I've already spoken about. So lower capacity per fiber pair, meaning that you can get more fibers into the system, which means overall more capacity for the entire cable. Lower power each wavelength, so that means that you have lower signal to noise ratio. which can be a bit of a challenge, but then is compensated for in the system and also by having many more fiber pairs. These are some of the examples of the cable systems that are either currently in force or currently being built. I think the Equiano one that we're all aware of was launched end of last year, and services have begun running on that system, and there's a bunch of others, as you can see, that are in the pipeline across the world, coming online in the next 2 to 3 years as well. So we see SDM as the future for submarine cable systems. It does not mean that there's no room for uncompensated fiber pairs, fiber systems rather, as we saw between 2015 and 2020. There's still room for those, especially on shorter spans, especially on unrepeated spans and where cost is an issue. But for ultra long haul, you're talking anywhere from 7,000 to 11,000 kilometers. We are likely to find SDM to be the preferred option. SDM is also not without its challenges. So administratively, we still have a lot of unanswered questions. When does one decide that a cable has now been come into service, because there's multiple fiber pairs in the system belonging to different customers, and within each fiber pair you could have multiple customers as well, separated by different spectrums. Who manages the spectrum? Who do you call if you have an issue? How do you test? How do you RFS? All of these things. A lot of these will be fixed with tools and automation, especially on the testing and troubleshooting side. But we still do expect some degree of manual intervention, at least in the initial 3 to 5 years, before the vendors, both on the wet side and the dry side, standardize how we manage, monitor, and logistic SDM cables. I mean, if you think about just the number of permutations you can have between cable landing stations on a 24 fiber pair system, it's totally insane. So, and this is just how complicated it can look. You can have multiple vendors, each with their own equipment. One has Sienna, one has Infinera, another one has Huawei. Talking into a common ROADM that is managed by the fiber owner, and then it could either be a full fiber pair, it could be spectrum, could be a combination of both. So it can get quite tricky, and a lot of this hasn't yet really worked itself out. We expect to gain more experience about actually managing a system such as this over the next, I'd say, 5 to 8 years. And in the future, well, apart from the number of amplifiers that you need to have in the system, which will determine spacing, the other thing that will determine the number of fiber pairs you can have in an SDM system is the actual size of the cable itself. So typical submarine cables are anywhere between 17 to 20 millimeter, which means that you can fit in between 16 and 20 fiber pairs within that system. If you try to fit in more than that, then you run the risk of micro bending losses in the fiber pairs, which obviously is not conducive for the optical signal. One of the ways that is being potentially looked at to fix is to reduce the size of the fiber core. So typical fiber core is about 250 micron. If that can be reduced to about 200, which is what we see in terrestrial networks today, then we can potentially increase that number in a 17 millimeter core to about 24, right? Vendors such as Corning and others are also looking at ways to reduce the thickness of the cladding, as well as the coating to anywhere between 100 to 130 micron. And if that does happen, in addition to any other advancements we can make on the power side, particularly using aluminum instead of copper as a conductor, if that actually does get to work, we could potentially have as many as 48 fiber pairs in the cable system. But that is probably another 10 years away at least. As of now, about 24 is just about the maximum we can do for the amount of power we can pump into the system, which is, not insignificant. So that's sort of where we are at the moment. Any questions?
fiber technique, that was very interesting. I have one simple question. You said they're talking about reducing the size of the fiber down to 2 microns. What was that done earlier on? Sorry, I'm not.
You mean the core down to 200 micron? Yeah. So that's being done already in terrestrial networks. So terrestrial networks already do support 200 micron. What tends to happen is the technology has to be tested first in the terrestrial before it moves over to submarine, and that's because there's been a convergence right now on the transponder side. So typically now the transponders used in terrestrial are the same ones that you get to use on submarine. So we haven't yet had that 200 micron come into the space yet, because the problem with the submarine is once it goes into the water, it's gone. You can't pull it out to fix it. So you have to really test it and make sure it's going to work and survive the harsh conditions of the ocean before we can deploy that. But that's obviously the path that's being looked at now.
I'm just curious why. I mean, I guess the 200 micron limit has been in use in, as you say, in terrestrial networks for a while now. Why the new cables wouldn't have done that?
Well, so also, so the 17 millimeter, which is the typical one that's used, would actually be a lot more, much smaller. I mean, the 20 millimeter might have a little bit more room, but subsea operators prefer the 17 millimeter because it's cheaper and it weighs less in the cabling ship, because weight in the cabling ship is a big issue also.
The cost thing makes a lot of sense. So follow up, because there's nobody else there. Because this is interesting, you're telling me that the evolution of technology is terrestrial going into sea, which is fantastic. Is there a teaser for what the terrestrial lab will be?
So one thing that's being looked at is another option to increase capacity, because at some point SDM is going to run out of spatial capabilities, because SDM fixes a spatial issue. But the thing is, spatial issues are not relevant to terrestrial people, right? Because you don't have that problem. So one of the possible solutions is what is known as novel fiber type. So you have multi-core fiber, MCF, as well as hollow core fiber. It's basically taking one fiber core and making more cores inside it, either with electronics or with some other special materials. But that fixes a spatial issue which doesn't exist in terrestrial world. So until the terrestrial world picks up on those novel fiber types, where you can have multiple cores within one core, for example. Think of it as virtualizing a core with more cores in it. Until the terrestrial picks that up, you're not going to see it in the submarine side, because you would, if submarine picked it up first, you would have to develop MCF or novel type specific ASICs to do the compensation on the submarine side. And customers and vendors don't want to do that because the transponders are converging between terrestrial and submarine. So if the terrestrial guys pick it up, then there's an ASIC developed for that, which can then translate immediately to the submarine side. So that's the other really coolish sort of, bleeding edge. I don't expect to see it for at least 10 years. But unless it gets picked up by the terrestrial side, you won't see it in the submarine.
Okay, thank you.
Sure.
Just a question on the amplifiers repeaters. How often are this spaced? I mean, are they like hundreds of kilometers? How are they fed? How are they fed? And do the vendors share the same amplifiers?
Right. So on the wet side, when you deploy, obviously you'd be deploying from the same vendor. So it will be one amplifier system, amplification system. And yes, so in an SDM system, it would be a single amplification system. The spacing will obviously be determined by the use case of the cable. So if it's a short cable and you want to maximize, capacity out of every fiber pair, then you could go with a shorter repeater spacing, typically anywhere from 50 to 80 kilometers, right? In that way, you can pump more power into the system, but then you limit the number of fiber pairs you can have. So in that situation, you're pushing for ultimate capacity per fiber pair. In SDM, you can have longer spacing, over 100 kilometers, 80 to 100 plus. And in that situation, because you're looking for overall cable capacity, ultimate capacity as opposed to per fiber pair, then you're able to use less power. In terms of power, we're looking at, you know, anywhere from 10 to 15,000 volts on either side. So between cable landing stations, right? So you get power from one end and power from the other, and you balance that out to achieve the kind of spectral efficiency you're looking for.
So the power is actually fed by copper?
Yes, the copper is the conductor that is in the cable itself, yeah. Yeah. Across the ocean, yeah.
You mentioned that, John Brown, you mentioned that the power feeding in was 10 to 15,000 volts. I'm just curious, is it AC, DC?
AC,
AC.
yeah.
What's the typical current draw on
Ooh, I'd have to check.
that? That's just academic question. I'm just kind of curious.
Well, it's a three-phase system, so we can do the math.
Okay.
Yeah.
Wow.
Yeah.
3 phases. Cool.
Yep.
All right. Thank you.
I'm Ed from Instance, I guess. Just out of interest, the APA coherent optics are not necessarily directly on the subsea cable side, but it seems quite cool stats for it to be able to do. Is that one unit is to complete everything you don't need to slot on amplifiers, or it can do, say, your 120Ks on its own?
Right, so the feedback I received from ADVA is that obviously it has the DSP, so it's tunable. So it does support WDM. It will run on its own 120K unrepeated, but it can also do about 900 kilometers repeated. Nice. Yeah. Although, to be fair, in real life, if you're going to run at that kind of distance, you're probably going to run a line system anyway. So I think it has more use case or more utility in metro.
Yes, hi, it's Carl from Miracle. It's not a very technical question, but I'd just like to know who's naming these fiber projects.
Beats me. Probably come up over some dinner and some napkin, I suppose, something like this. Well, I mean, the names there's meaning in the names. I think Dunant, for example, there's some history here that Google picked up. Dunant was, oh gosh, it's going over me now. Somebody that did some project in Northern Europe where the cable lands, because the cable lands north of Europe, yeah. So I've done it, yeah. So I think there's some history to the names, but Equiano one I think was honoring some Ghanaian man. I keep forgetting what the story was about, but there's a Ghanaian, a West African man, in whose honor Equiano was named after. To Africa, I think To Africa got renamed, right? To Africa was originally something else. Simba, there we go. And yeah, I think Hollywood made some fuss about Simba and so forth, you know, rights reserved and stuff. So yeah, it's the whole thing. Others is just an acronym, like I think Medusa is an acronym for Middle East and, you know, South Europe and this and that and the other. So,
All right.
yeah.
Bifrost, I can see that the
Yeah. Apricot, yeah, I need to look into that one because obviously we have a whole conference in Southeast Asia. So, but yeah, the naming sometimes can be a thing, sometimes it can't. But yeah, all right. I know, like the one I first deployed in Japan, between Japan and Los Angeles, was called Unity, because it was the first cable that Google got into with a bunch of telcos. I think there was KDDI, there was us, there was NTT, Singtel. So because it was the first time telcos and content people were coming together as united front, they called it Unity. So all manner of naming, you know, reasons.
Any other questions or comments? Great. Thanks, Mark.
Thank you.
All right. So next up, we have Salam, who's going to chat with us about Netflix routing. Ta-da.
Yes, thank you.
Great.
Thank you, John.
Thank you.
Well, I'm not sure it's going to be about routing, but let's see. So good morning, everyone. Yes, I'm Salam Yamout. I'm based in Amsterdam, and I'm the Partner Engagement Manager for Netflix, responsible for Africa. So we are an entertainment company. I always like to start like this. Yes, we do have a technology component, but basically we make films, a lot of films, and we stream them. So we have reached 230 million subscribers worldwide, and we have 100 million on top of those, like a third, that share password. So, yes, it's coming. You're gonna be receiving this email. So we have one application in 80 countries, and it works on desktop, laptop, TV, tablet, mobile phone, all languages. We call it the product, and then we do some crazy stuff with it. So what's new at Netflix? I didn't have enough slides, so I'm going to talk them. So as you know, we started our first live show on the 12th of March. We transmitted live an American comedian, David Rock, Chris Rock. Yeah, live. About 1 million people watched it live, but none of these people were in EMEA because it was 3 o'clock in the morning. But this is something that we are going to repeat. So a lot of things are changing in Netflix. We will be doing live. We are going to chase the password thing. We're doing business with ads, which is a new plan that has ads in it that will be placed at a lower price for people who want to do this. And also, we're filtering routes. So we have been members of Manners for many years now, but finally we have started filtering routes that we think are route leaks. So what do we filter? We filter any route that doesn't have a valid ROA, so all invalids are dropped. And also, if you have a customer, you are our partner, and you have customers and you are advertising your partner's routes, which is, you're advertising your customer's routes, and this is totally acceptable with us, except that these routes have to be registered in your AS set object in Afrinic database, or ADB, or any other public database. Okay? So if you're a partner and you're wondering why these customers are not being served, so you either have to update the AS set object in the Afrinic, in this case, database, or you have to remove these advertisements from the OCAs. It's a good time to be talking about this because I hear tomorrow there's an RPKI training session that I will be personally attending, and I think it's so easy to just do a ROA or just change your AS set path, and there's no reason for anyone not to be doing this. What's also new is out of April, it's going to be a year almost now, we went to RTUDC and we pledged that we will be having 80% connectivity for all, if you want, underprivileged or like communities. So we are now, and I'll talk a little bit about it later, we are going into something that we call the RIX model, Routerless IX. That means, well, let me go into it right now. So these are the different ways that you could partner with OpenConnect, our CDN. So first, an ISP could do nothing and get all the movies and everything from transit, right? This is what any ISP could do. The other way that you could do is, that's new, that's our IXP, Routerless IX we call it. I don't know why we call it this way, but we, in this case, give caches to the IXPs directly. And in this way you can be a member of an IXP, and that IXP could have caches, and you could get the Netflix service through your membership. The third way you could have a relationship with Netflix is to be at an IXP where we are also present. So there are cities where we are present: Chicago, Milano, Paris, Rome, Romania, Bucharest, In every place, Johannesburg, Nairobi, everywhere that we are present, we have a POP, then we will be a member at the exchange that is in that city. So you could also public peer with us through the local exchange. You can also have a private PNI with us, or you can have your own embeds That means you put the caches in your own network and you serve only the customers that you choose, or only the prefixes that you choose to serve. So this is at a glance, everything we can do. In all cases, you have to establish a BGP session with us, either directly with us or between your router and the OCA, almost all the time. So it's always good to know BGP, of course, and to practice it well. What I see, because I'm dealing with Africa and some other regions, I see that the African ISPs have a tendency to advertise a lot of routes, more than like my bigger partners, say in countries like France or Italy. You have pages and pages of prefixes. I never understood why this is happening. If somebody knows, please let me know. I think that there is an over-advertisement. Maybe I'm thinking maybe people do not have a clear routing policy to segregate, say, this is my peering route, these are my transit routes. Why do I need the rest? Anyway, I don't know, so I'm putting it out here just as a question. So this is a close-up on the newest model, the routerless IX. Which is working very well in Africa. I'll show you in a little bit. So we'll give the caches to the IXP. The IXP would have to have a router that speaks to the internet. And then all members would have to opt in. If they want the Netflix service, they will opt into a specific committee, and then they will have the Netflix service. If the members already have embedded OCAs, or if their transit provider has embedded OCAs and advertising their prefixes, then they will not be served from the RIXP. Anyway, if you know any country that has an IXP that would like some caches, if you know any IXP that is, say, charging too much or giving you a hard time, just come and let me know. I'm here all day today, all day tomorrow. So a little glance, so as I said, we pledged 80%. I'm happy to say that in Africa, 81% of the African traffic is served from Africa. The 19% that you see are coming mainly from Europe, mainly from Paris, Milano, London, Frankfurt. These are the big hubs. And some is coming also from New York City. It's a shame. My goal, my personal goal, is to have 80% local traffic in every African country. That's what I'm working towards. And this is where I am right now. So we do have 2 POPs in Africa. So if you are in Nairobi, or if you are in Johannesburg, you can have a PNI with us directly. It costs you nothing. It costs you for the port. It costs you nothing to get the traffic locally. A lot of players, big players in South Africa, we invite them also to peer with us in Kenya, in Nairobi, so that we maximize the use of these 2 POPs for Africa instead of getting the traffic from, as I said, London, Frankfurt, etc. And all the purple little dots are the routerless IX. I'm very happy to say that we are already, and our first was Sinks and Dinks. Where's Donald? Donald is here. He's the first partner here. He's the one who started all of this. And then we're also going to have, hopefully, also with Napa Africa in also Cape Town and Durban. So we have a good presence in South Africa. In addition to Jinx and Napa Africa in Johannesburg, we're going to have also presence in Cape Town, Durban, and maybe Port Elizabeth. Ed, we're looking into this. Okay, other countries, so we have now the following IXPs have their own caches and can give you local traffic in the following countries. So we have Uganda, Tanzania, Mauritius, Nigeria, Burkina Faso. So I'm very happy about that. And as I say, if you come from a country or have friends that have independent IXPs, open IXPs that accept all members, please come and let me know. We're very interested in giving them caches. I think that's it. A little just a little reminder for me is important. I don't know, maybe for you, it has nothing to do with routing. So for us, local streaming doesn't only mean delivering the content locally, which as I see, I am really trying hard to do. But it's also working with the communities into making films. So we are a film company. We are making films in 44 countries. I'm very happy to say that we have content that is being made in South Africa, in Kenya, in Nigeria, as we speak today. Local films, local titles. We also have like a scholarship fund. We send people to school, and then also we have a program for young talents to find their first job with Netflix. That's it, thank you. Any questions?
Any questions, anybody?
Good morning, Mark Alkins. Thank you very much. Thank you very much for having a presence in Johannesburg. It makes my life very happy. And that obviously helps me. My big bugbear with Netflix is the regionalization, where you can only see certain media in certain areas, which of course we can get around with virtual private networks, etc. Because we've got virtual private networks, my question is, why do you still insist on doing regionalization of what you can see from a particular region? Because that becomes a real bugbear, especially if you're trying to travel somewhere else. You're watching something and then suddenly you can't watch it where you go, unless you then go out and get all the VPNs up and running. Thank you.
Yeah, thank you, that's a good question. Actually, we changed this policy, so everything that says Netflix original, you can see everywhere in the world. Everything. So when the thing starts, it says Netflix original in so many languages. This, you're able to see anywhere. That's no restrictions on this. If your local cache doesn't have it, we'll go and get it from the nearest pop. We'll get it from Johannesburg or from Kenya for Africa. Okay? What you cannot see everywhere is licensed content. That it means when we buy a film that's already been finished or published by somebody else. And this is because of copyright laws. When we buy a license, they usually sell it to us for a certain geography. This is where the limitation is. So I guess you have to tell your wife to watch original Netflix content.
That's Justin from Washington. What is the minimum bandwidth requirement for to get an embedded OCA? Is it 1 to 5 gigs or?
Yes, so officially we say it's 5 gigs on our site. You know, so you have to have 5 gigs of traffic. However, for Africa, I am doing 1 gig. Okay, so if you have 1 gig of traffic, you either can get a PNI or you can get an embedded. Yeah. This might change, by the way, because as we reach saturation, you know, this might go back to be, especially for South Africa, 99% of the traffic in South Africa is served by the POP in Johannesburg, so, and by the several things that you saw. So that might go up a little bit for South Africa specifically because you're so developed.
Hey, I'm Lily from Denmark. I saw the dots on the coverage for yesterday. Okay, so what interested me was like one presence in the Congo where there is PXPs. And
in where?
In Congo, in the DRC. So
yeah, in Congo. I forgot to mention it.
Why is there no cash in the DRC in the sense that it's a lot of population and there is already PXPs in the country? Why do you think there is such a delay?
Thank you. We are also in DRC, in Democratic Republic of Congo, but I did not put it on the list. Thank you very much. So yes, this dot is real. We are in Kinix? Kinix. Yeah, we are in Kinshasa, and I think we're going to put one on the border with what? No, not Gop. No. Another one. Mumbashi, thank you. Mumbashi, yeah. Yes, thank you for that. It's a mistake. So we're also in DRC. Hi.
You briefly mentioned plans and thinking of Elizabeth. Can you kind of mention what are the indications, what are the things that you need to see to make
Very good question, because that's what we have to discuss. So our criteria for routerless IX, okay? So it's going to have to be you have more than 5 networks connected, and you're also going to have a little bit more than, close to 5 gig of traffic in order to deploy. However, what I've been told, I've been listening, especially in Africa. I've been listening, and people have told me that when you get the Netflix service into an IXP, a small IXP, this will help it grow. This will help it. It's like we're acting as anchor tenant. So in this respect, we are not really doing Netflix best interest, if you want, but we're listening to the communities. The communities are telling us, come and be an anchor tenant, and then we'll have more members, and this way we'll be contributing to the local traffic distribution. And so I'm willing to listen. No, Ed, no.
The whole peering ecosystem needs the supply and it needs the demand. So you're helping to meet the supply side of that equation.
Yes.
What I'm seeing, being an open access network and operator of last mile networks, at the moment, our infrastructure and the way the ISPs expect us to deliver the infrastructure is that every customer in Eastern Cape is backhauled to Cape Town and offloaded in Cape Town. Nobody is delivering content that I'm aware of. Okay, you're special. But none of the ISPs who are using the open access networks that I'm aware of are delivering content right now within the region. So the cache that you've got is going to be great. The problem that I'm seeing that we're not yet properly talking about is that the ISPs are going to put their pop there. The customers that are in Port Elizabeth are going to trombone back to Cape Town to reach the cache in Port Elizabeth.
Yes. It's true. You're absolutely right. The caches do not solve all the problem. The caches will offload between 70 and 99% of the traffic, depending on what people watch, right? But there's this daily fill, right? You have to fill the caches every night between midnight and 12 with 500 megabits per second. So there's the fill traffic to take care of. All things considered, every IXP managing his own or her own IXP has their own prerogatives, and at the end it's a small calculation that will tell you whether this fill traffic is worth to my members. And what I've seen happening, we started like in Beirut, when I started the Beirut IX, we did the cash farm because at the time we were paying $30,000 a month for 1 gigabit of international transit. It was to Marseille or to I don't know where. $30,000 a month. So of course for us, we wanted the Facebook, the Google, the Netflix caches, and we all divided the cost among all the members, and it made sense for us. So if it makes sense to divide that traffic up or to have the local IXP carry the content and have all the members divide the cost, and it's less than what you would pay for, just you bringing all the traffic from Cape Town, it makes sense. If it doesn't make sense, that's not for you.
So we'll do one last question because this is between coffee and questions. So,
Carl here from Eurozone. I just want to find out what's the requirements to get a PNI connection?
The PNI is also, in Africa, is more than 1 gig, yeah.
Okay.
Yeah, more than 1 gig.
great. That's some
Thank you.
cool stuff. Thank you very much. All right, so we are now up for a break until the top of the hour.
Thank you.
So let's be back right about 11 o'clock, and that'll give us plenty of time to get some coffee, stretch our legs, have a smoke, will have
We broke it now.
Oh, we did break it.
Okay.
Yeah. There are too many people driving. Ta-da!
Ta-da.
Take it away, Graham.
Thank you very much. Everybody hear me? Good stuff. Okay, so the title on the agenda ended up being a bit long to actually type out, so that's what we've ended up with there. And yes, this is a talk about layer 2 networks, kind of quite general, but obviously, I mean, I'm from Vumatel. We're a local open access provider providing layer 2 connectivity, amongst other things, for a number of ISPs, so many of you are probably using our services. And so I just wanted to chat a bit about what we are seeing, some of the general stuff, and then hopefully have a chance at the end to chat through any questions you might have. So that's me. There's some contact details there if you need them. And then, yeah, what we're going to talk through some of the kind of the fundamentals, some use cases and challenges, and then hopefully some solutions. Okay, so looking at layer 2 versus layer 3, and I realize that this is kind of sort of 10, 15, 20 years ago. A lot of what we do currently is not exactly this, but the essential idea was that layer 2 was a flooded broadcast, every endpoint on the network type of protocol, and forwarding to a specific individual interface is something that came much later at layer 2. It is now fairly standard in most switching equipment. That's why we call them switches and not hubs anymore. But fundamentally, it's a recent thing, and a lot of the basic functionality of layer 2 still assumes that a broadcast or flooded to all interfaces will continue to work. By contrast, layer 3, as we all know, unicast goes one direction, goes to one endpoint. If you want to get it to go to multiple endpoints, you have to work very hard and you have to fight with routers and battle them with multicast. And I don't know anybody who's not got war stories from trying to do that. And the big difference from a networking point of view is what happens when things go in the wrong direction. So at layer 2, there is no hop counter. Now the hop counter is something that's attached to each packet, and at layer 2 there is no hop counter. So a network packet will arrive on a device, and that device will look for a place to send it forever. It will never stop looking for places to send it. In the loop scenario, so when a packet comes round and ends up back on the same device, that same device will see it again, have no idea that it's seeing the same packet, has no way of knowing it's the same packet, and it will look again for some way to send it, and it will send it again. And that creates packets that circulate continuously. And then when you have a scenario where, for any reason, that packet is a broadcast packets are intended to then go out all of the interfaces on your networking device. And that creates an amplification effect. So one packet comes in, it gets sent out 4 times, it goes around the loop, it's now four packets, it arrives back. Oh, we've got 4 packets, multiplied by 4, suddenly we've got 16 packets. And this breaks networks very, very quickly. By contrast, on layer 3, every single packet has a time to live or a TTL marker on it, and once that packet has passed through a certain number of devices, and I actually don't remember what the limit is, but it's sort of 50 or 100 or something, so it's a very big number, but I think it's 50 or 100. Does anybody know? 255, is that? It's also different per operating systems, I think, or it used to be, but yeah, 255. But the point is that although that's a relatively big number, you have to have gone a long way around the internet to have gone through 255 routers, but there is an endpoint. When you get to the 255th device, the TTL is at 0, and that device throws the packet away. And so you suppress that. If there's ever a misconfiguration, if there's ever an issue in the network, the traffic just disappears. So it's inconvenient. I mean, your packet's not going to where you want it to go, so you don't have connectivity, but your network doesn't implode. So where are we seeing layer 2 in use? In the data center and enterprise. I've seen a lot of this. I previously worked for an enterprise ISP/MSP. We worked with a lot of enterprise users. We worked with a lot of data center environments. And a lot of people in those environments like layer 2 because it's in their own space. So if they're running a server in a rack and they can connect between all of the servers in the rack without having to worry about the router or the firewall that sits in the other side of the building belonging to the other department, then they're happy. And then they get used to working within their one rack and they say, oh, well, I need to be on the other side of the data center as well, and we'll just get that layer 2 to the other side of the data center. And then the next day they go, oh, well, I need another data center on the other side of the town for DR. Well, let's just extend that onwards towards there. And you end up with these layer 2 domains that just grow and grow and grow because it's something that people are familiar with. It's not going outside of what their knowledge area is. But also we see that people are recommending, software designers recommend that you do your redundancy with this particular type of protocol that only works on layer 2. You've got a cluster of servers and they have to be connected together at layer 2, otherwise they're just not going to fail over or whatever they're needing to do. And then even on the LAN side, we see the same thing. Users who build enterprise LANs, who get comfortable with big layer 2 networks, and when they need more endpoints on the layer 2 network, they just make the layer 2 network bigger. And if they need a new branch, they just plug it into the edge of the layer 2 network. And they don't have to worry about these horrible things called routers. And they don't need to worry about buying these horribly expensive things called firewalls, and they don't need to learn about these horrible things called routing protocols, and it's simple. Unfortunately, it doesn't scale. And then there's the big one at the bottom, and this is a misnomer, I think perpetuated sometimes by us as the operators as well, that when you do a trace route, every hop line you see in the trace route is somehow killing your performance. So if there's less in the trace route, you've got a better service. And so people then hide away bits of their network by doing it all in layer 2 just so that their trace route looks shorter. Now, the reality in modern networks, well, not even in modern networks, the reality in networks is that if you need to get from A to B, you need to go through a certain number of devices to get there. Whether your diagnostics tools tell you that you're going through those devices is largely irrelevant. You're going through those devices. And so not seeing them in the trace route doesn't give you better performance fundamentally, but there is this false belief that somehow you're getting better performance by having more layer 2 and less routers. Now, in my view, 90% of these problems can be solved with DNS at layer 3. You don't see Google coming to you and saying, no, you must bring a VLAN into our data center in order to get google.com. You don't see Facebook coming and saying, no, but you have to do VRP and you have to do it on this. The way that the big guys do it is they send you a DNS address and they shuffle you around and they send you to a different server to get the content that you need. And we have a lot of people, and this is particularly in the enterprise space, but I see this also in the ISP space, and we are doing people a disservice by not guiding them in the direction to say, well, couldn't you do that with DNS? Couldn't you have your failover to your backup site where you actually have a different IP address on the server in the other location? Because that's better for network design. That you then, when you want your website to suddenly come up on your backup server, just update the DNS record and you point at the new website. Now, kind of more into the area that I'm working in at the moment is access networks. So circuit-based services, dial-up modems as they were back in the day, and even ADSL to an extent, were circuit switched. So you had a point-to-point from your device through to an endpoint. as things have evolved, most of the modern technologies, the PON technologies, the fiber to the home technologies, are no longer using any of these specifically circuit-based technologies. They're using Ethernet type switching and layer 2 switching. The mobile network architecture still effectively from your phone into the core network still creates a circuit, and so the mobile networks are still kind of in a funny space there where they still have the more circuit-based architecture, but even they're moving in different directions. And so in order to have open access fiber to the home at scale, you're needing these big layer 2 networks. And these big layer 2 networks fundamentally require broadcast messages to go over them. Going back to what we said at the beginning, originally layer 2 was a broadcast protocol. And so these protocols that are running over the layer 2 networks require broadcast to be able to function. If you can't send a broadcast message over your FTTH provider, the triple PoE discovery, which is the first step in connecting, never gets through, and your ISP can never give you a connection. If you're using DHCP, that first step requires the broadcast, doesn't get through, you never get connected. So we have to allow broadcasts, even though there is a significant risk in allowing those broadcasts, and that creates a risk in the stability of the network. So as we have mass market adoption, I mean in South Africa we've got fiber to the home in most of the city areas now. There's massive work going on at the moment to get fiber into the more rural areas, underserviced areas, and things like that. And that requires internet access at scale. And because of the back-end technology, that means that we've got layer 2 networks at scale. So challenges that I see with the networks we build at Vumatel, and also with the expectations from ISPs in the industry, is that people want to do centralization. People don't want to have to deploy a POP in 15 locations around the country. People want to put an IP POP in Johannesburg. They want to service the whole country from Johannesburg. When you get bigger, some of the bigger networks will then start to move out, and then they'll go Joburg, Cape Town, Durban. Then they've got 3 POPs. But there's basically no ISP running on an open access network, and this goes back to the conversation we were having about Netflix. There's no ISP in this country that has got more than 3 POPs delivering onto the FTTH networks right now. So everything is centralized in either Joburg, Durban, or Cape Town. Then we have open access, so we have ISPs wanting to deliver services over the open access fiber networks. And what that means is that we've then got ISPs with their own particular set of requirements, their own particular architectures, the number of devices they want to do, the kinds of CPEs they want to use, all these different dynamics that you then don't have control over, and they're doing it over third-party networks. And open access in South Africa ends up being the perfect storm of the two of those together. And as I said earlier, Layer 2 is a fragile protocol. It's being used beyond what it was originally intended for. And there's a continuous trade-off between scalability and stability and the cost of those two throughout the entire value chain. ISPs don't want to build POPs. The fiber network operators don't want to have infrastructure in places where it's underutilized. It's a continuous challenge. So we are some pain points here. MikroTiks are used by a lot of people in this country, a lot of ISPs in this country. I like them, they're very useful, but they also take certain things with a bit of enthusiasm that's not typical of some of the other vendors. And they're less conservative. Let's say they're less conservative than the other vendors, and that means that they're very innovative with some of their capabilities, but less conservatism is again a trade-off with stability. So neighbor discovery protocols are standard across most vendors, but MikroTik takes it a step further. In order to be universally compatible and work with every single other device, every single neighbor discovery packet that a MikroTik sends is not just one packet. They send 3 packets. One for the Cisco protocol, so the Ciscos can see the MikroTiks. One for LLDP, which is kind of the more general standardized protocol. And a third one that's their own proprietary protocol. And they send all 3 of them every time. So suddenly you have a device that's sending 3 times as much noise into the network as a more traditional conservative vendor. They also, by default, don't only send those discovery protocols on their physical ports. Most other vendors will only send the discovery port on the discovery protocol on the physical port, whereas by default, MikroTik sends it on every single VLAN, every single sub-interface, every single bridge, every single component. And so a single router can be sending out tens or even hundreds of these messages every cycle, which I think is about 1 minute or something. They also have these other useful things. MacTelnet, I'm sure any of you who've used a MikroTik will know about MacTelnet. It's a great management tool when you've completely messed up all of the layer 3 config on your device. And it's a backdoor, and you can get in and you can fix stuff and you can get yourself out of trouble. But you should only be using it to get yourself out of trouble. If you are using it as your default management tool, then you should be rethinking that. We've had ISPs come to us and demand that they allow us to do MacTelnet across our network because that's the only way that they can manage their customer routers. And I'm going, your customer device should have an IP. If the customer device stops having an IP, then that's a problem. And there's plenty of protocols that exist that have been developed by the people who've built big networks to do auto provisioning and to do remote management and do all of those things in a scalable, sustainable way. The important point here as well is that MacTelnet, people assume that because they're typing a MAC address into the message that they're sending a message directly to that MAC address. But the way it's implemented on the MikroTik is that the MikroTik just sends a broadcast message. So every bit of communication that you send to your device is being broadcast to every other device in that VLAN. And as far as I'm aware, that's all still unencrypted. So any customer who happens to do a bit of traffic sniffing on their port can see the username and password that you use to log into their neighbor's router, which is probably the same one that you configured on their router as well. Security problems all around. So use the tools in the right place, but understand the limitations and, yeah, use with care. Another one I've seen is spanning tree protocol. Spanning tree is very old. The people who designed spanning tree have said it's very old and it's not really suitable for today's requirements. It's a very blunt tool for managing networks. I've only seen it work really well in extremely simple networks that either have one single ring or maybe a ring with a little sub-ring on it. Anything more complicated than that, the moment you get into a network that is meshing or is getting more complicated than what a simple single ring, you're going to start having challenges with the spanning tree, and a lot of people then just get frustrated because spanning tree is not the kind of thing where you just plug in another device, plug in another device. You have to design it at the beginning and you have to make sure it works like that, and you have to redesign the network if you want to change it. And that's not how networks are built these days. We're plugging in new network components all the time. So the first rule there is, if you really want to use spanning tree inside your network, and I would say that it's a good idea to consider whether you should just turn it off completely because it might not actually be helping you. But if you really want to use spanning tree inside your network, never send it outside of your domain of control. So your data center, your rack in the data center, whatever, if If you want to do span entry there, that's fine, but don't send it to your transit provider. Don't send it to your backhaul provider. Don't send it to your access provider, because you're not saving yourself from anything, because your provider is not going to interpret those span entry messages and make decisions on them in any way that you might think they will. So it's not benefiting you, and you're just flooding more garbage into the network that is not helping anybody. Similarly, you should not accept span entry messages from anybody, and you should not act on span entry messages from anybody, because if your network and their network have not been designed together as part of that span entry architecture, there's no way for them to interpret the messages that they see. I've seen a lot of people who insist on using BPDU guard and then screaming and shouting when their interconnects at the data center shut down. But you can't control what's coming from third parties, so don't use BPDU guard. BPDU guard is a LAN, office LAN, enterprise LAN feature. It doesn't have use in the data center. And if you need redundancy, look elsewhere. The layer 3 underlay with layer 2 overlay products, or protocols rather, are mature, and at this point like 10, 15 years mature. They're available, they're high performing, they're available built into chips from just about every vendor. There's really no reason to not be using something like MPLS, VXLAN, or there's a few others as well, but those are the two most people know about. There's no reason to be not using one of those rather than trying to connect everything together at layer 2. Storm control and port security, related again. And again, to the point, don't trust anybody. Assume that your neighbors, the people you connect to, the people you interconnect with, your customers, your providers, even other organizational units within your business. If you're the ISP department and your IT department is now a separate team, just don't trust them. Not because they're implicitly bad people, but everybody makes mistakes. Put the safety nets in place that you're not going to get taken down by a mistake that somebody else makes. Storm control, limiting the amount of broadcast messages so that when that condition occurs, that you have the traffic looping, that it's amplifying, that you create some kind of limit that stops that from getting out of hand. But take care when you're doing that, because like we said earlier, PPPoE, DHCP, those protocols all need broadcast messages. So you can't just block all of your broadcast messages, you have to set a threshold, and you have to, it's actually important to go and figure out how much of this is on your network, give yourself a safety margin for your growth in your network, whatever, and set the limit, so that the broadcast messages can never consume all of your traffic, but there still is enough for what's going on in your network. The other important thing, just to specifically on broadcast storms like this, in South Africa, remember that when we come out of a load shedding stage, you have thousands and thousands of subscribers coming back online at the same time. So whatever you're doing in terms of storm control, make sure you're planning that out, that allows for that peak, that as the users come back online, as they're trying to reconnect, you have enough headroom in your thresholds that they can all get online quickly, because customers have been sick of having no power and they want to be back online the moment the power comes back on. And then port security more generally, set reasonable limits for what you're allowing into your network. A customer plugging in a single router has no reason to send you 100 MAC addresses. So set a limit that's reasonable, because by default, the equipment will accept whatever you send. And then something specifically that we're also seeing on the fiber networks is these junk people send, intentionally, unintentionally. Only allow the stuff that's needed for the service you're delivering. So if you're delivering PPPoE services, only allow PPPoE ether types to come through, etc., etc. We've had scenarios where people have bought some kind of weird HDMI repeater thing that happens to have an Ethernet cable on the back, and, oh, this is cool, it's got an Ethernet cable, maybe it'll plug into a switch. And it does actually plug into a switch because it's talking Ethernet. Only problem is that the little HDMI repeater box is so dumb that it's just got a hard-coded multicast MAC address on each side, and they're just chucking multicast frames, and a network device doesn't know what to do with it and goes, well, I don't know what multicast is, so I'm just going to broadcast the stuff. And broadcast sends you, the user's watching 4K HD content, and the next thing, some little consumer device is flooding the network with junk that is irrelevant to the service you're trying to deliver. The last big one is, I know everybody's bought a bunch of these secondhand. Everybody has. I've got them as well. But please throw them away. There are known bugs with them. You can turn on storm control, you can turn on rate limiting, you can turn on VLAN allowed lists, and the packets still get through. There's a bug with IPv6 multicast packets that they just pass through the switch and they don't stop. And we've had incidents where somewhere someone started an IPv6 multicast packet, got into an ISP's network, stormed inside the ISP's network, got into our network, stormed in our network, got back to another ISP's network, stormed in their network. That ISP then carried that traffic from Joburg to Cape Town on their backbone, because their backbone was just a bunch of switches all connected together on layer 2, stormed back into our network in Cape Town, and took out half the country's internet. So the one use case that I still see for these is if you've got servers or routers that you control that are in your environment, sure, carry on using them. But if you've got one of these connected to a fiber operator, connected to a backbone link, or connected to any third party like a customer, please just throw them away. So in conclusion, don't underestimate layer 2. It's easy to get started, but when it gets big and it breaks spectacularly. And keep it clean. Again, plugging it in the first time, everything works, it looks wonderful. But when you've plugged in 10,000 first times, you suddenly have a lot of mess. And you end up with a lot of noise, because a lot of devices have these broadcasts, these neighbor discoveries, all of these little things that they do that are convenient and useful, but at the scale of tens and hundreds of thousands of these devices, it creates a lot of noise. And always look for ways to solve the problem that you're trying to solve with layer 2 at layer 3. I know there's been a lot of discussions over the years between the ISPs and Vumatel on the open access and how the open access layer 2 model is, the ISPs like it a lot because it's convenient, they can put down a triple PoE BNG server, and it works very smoothly, but it doesn't scale. And we're at the point now where difficult decisions have to be made to say, well, if we can't keep the layer 2 network safe and stable, we have to move to layer 3. And everybody hates OpenServe's layer 3 model. But there's a reason that it exists, because it scales and it's stable. So, yeah. Work with us. We're keen to carry on delivering stuff, but we're also keen to make sure that it's stable. It doesn't break. Okay, I'm done. Any questions? Are we doing questions?
Got a couple moments for a few questions. Anybody with comments?
Hi, so with regard to last part of security between customers, especially with retailers deployments, I've seen, I want to say for business specifically, but I've seen GPON providers who have customers all visible at that level at the edge to there. How have you fixed for that? Or what have you seen in the worst?
So most of the vendors have got some kind of button or knob that will do some kind of isolation. And in different places it works. So in a simplistic term, if you're talking about a single OLT or a single access switch, you do the Cisco calls it what, private VLAN or something, and the other vendors have got client isolation. There's different names for it. And within the domain of a single device, generally it works. Where I see it failing is when it then has to go back into a bigger, as you say, VPLS network. There are ways of doing it with VPLS that in theory should work, but it becomes a very specific sort of design thing about being very specific about where you build each tunnel and where you terminate each tunnel, and considerations around redundancy. It does get quite complicated. So right at the customer edge within the context of a single neighborhood serviced by a single LT, certainly that's something that you shouldn't accept as happening. It should be blocked. But we do see a scenario where as it gets further into the network, depending on how, and also depending on how the network's been done. VPLS, it's a manageable problem. If you're talking about a backhaul network built on ERPS or spanning tree, there are pretty much no ways of actually dealing with it because the traffic's going back via the backup route, and there's a link failure, and then you start seeing people on the other side.
Jared Launch, Fine Technologies. I'm curious in part about how the open access networks are actually working here in South Africa. What we saw in the US is we saw in the late 90s, there were these two big providers, Cobad and North Point, which are both now, John is over there laughing, but they're both now defunct because the open access model, and line sharing agreements and stuff like that really didn't work at scale. And I'm kind of curious how that's, how that actually is working at scale here, or maybe in part maybe has some challenges here. So you mentioned everyone's backhauling to the same, couple, locations. But at least then we would get a handoff, like it would basically be, an ATM interface, but now you can do that probably with VLAN, or a trunk, VLAN with, or a trunk port with a whole bunch of stacked tags, and stack them inside there, so you get more than 4096 on a port. Is the access model that they hook up to an OLT, like the end user hooks up to an OLT, you assign them to a VLAN, that's the VLAN for that single provider, and then they just backhaul it nationally?
Yeah, correct. So I mean, certainly from our point of view, we try and segment it into the three major regions where the three major data center clusters are. So we try and avoid national, but like I said, there are ISPs who like to be just in one city and just open access to the whole country. Broadly, there's two models that are at play. So the one model is configure the VLAN at the OLT, and that VLAN ID matches a VLAN ID that's allowed on a switch to the ISP, and that VLAN just gets all the way through. Mark will tell you how much the ISPs love that because it gives you a lot of control to pretty much deliver whatever kinds of services. You've got a lot of control over kind of what you're doing with the service delivery. The other model that we've got is with various different variations, but where the open access operator operates a BNG, and in some cases with L2TP, I think, you probably know that protocol better, L2TP, and then you're terminating on an ISP LNS, so that's IP from the BNG. It's a good model. It ends up being very expensive hardware-wise. So that's the model that the incumbents telco currently uses, but all of the competitor FNOs like myself and all the others didn't go for that because it's got massive capital costs up front. But it actually scales much better. And then the third model that we use is kind of similar, terminating on a fiber operator-owned layer 3 device. We've got both BNGs and DHCP gateways, and then dumping out into a VRF. And then each ISP gets their VRF handed off to them at the interconnection point. Again, that scales, but then the ISP doesn't control what IPs are allocated. The ISPs don't like it because they have their hands tied. There's challenges with the amount of IP space, obviously, with IPv4 running out. The ISPs are trying to squeeze like every single customer, and you've got it becomes a management challenge it comes with other challenges, but the scaling, it works very well.
Okay, and then I guess, I guess my last question would be, have you thought of just delivering a managed routing service for them? It sounds like that last thing that you mentioned might sort of be it, or something where you use a Tomahawk 2 chipset device, which are relatively inexpensive. seems like some sort of intermediate service that in there may be helpful.
So as Vumatel, the service we deliver to the lowest income areas is pretty much that. We own the ONT, there's no ISP router, we configure it all remotely, managed through the OLT management systems that exist, the technologies that exist there already. And in that scenario, we control and manage all the way from essentially the Wi-Fi in the user's house, all the way to the interconnection point, and then again, we just hand off that VRF with that pool of IPs that belongs to that ISP. They do the internet breakout beyond that, but everything inside of that is then managed, and it does scale better.
All right, last question, real quick, Ed.
Yeah, just a quick one on your thing about people not necessarily breaking out in a smaller region, everyone funnels into bigger areas. I think the biggest issue there is that many FNOs make it expensive for that to happen. We know one big FNO recently pushed up port pricing and forced people up to 10 gigs. And what they've effectively done there is funneling people's traffic to Joe. Because people are now suddenly consolidating because it just doesn't make sense for them. People who do a great open server, if there's some infrastructure facility, it's super cheap to run almost from anywhere. Same thing with EFA and Africa and those ones. But that's mostly these business services. But I think if there's a want for it to happen from the F&O side, if you make the conversions make sense for like, oh, you already are on 3 areas, you pay whatever prices, we need a full area, make it free. That's how I would see it make sense. Instead of trying to price them into splitting it up into, or not split it up. So, yeah, sorry, it's in this case.
No, I agree, Ed. I mean, there's a lot of good reasons to incentivize. I mean, certainly from my point of view, I don't want people picking up their traffic in Joburg because from an operational point of view, that's more trouble tickets that get logged with me to say, why is my latency never below 20 milliseconds? I was like, well, because that's how your ISP chose to design their network. And I don't think that's the service we should be delivering. But yeah, we have to have complicated discussions with bean counters to make some of those things work.
With the P exchange happening, it's our goal to try and make that more easy for people and make more sense, but it needs that most availability, so we can push for more study for people.
Okay.
All right, great. Thank you, Graham.
Thank you very much.
All right, next up we have 3 lightning talks. They'll be about 10 or 15 minutes each. Our first one is going to be Yolandi, and it'll be, why we are so far behind or something like that. Anyway, she'll be the one that will be able to excellently answer what the talk is, and I'll get her slides up here real quick.
Just hold this, please.
Let's see. How far behind are we?
And this one is in your pocket.
Technology work. There you go. Thank you, Yolandi.
Cool. So yes, hi, I'm Yolandi. And the presentation is how far behind are we really? So from my experience, I've seen a lot of the people in the room is far behind because they don't know where the dinosaur comes from. So that's, that's when you do not have an internet connection and you are on Google Chrome. Google entertains you with this little game that you play while you are offline. My personal high score on this is about 16,000. So yeah, I was disconnected for quite some time. Anyway, so we will be looking at Africa. Now, the thing we have seen, I mean, obviously over the years, is that when we talk about Africa and technology is mentioned, we tend to think that Africa is very far behind, right? You know, the US and Europe are always the leaders in technology and internet and connectivity. So this year I thought, okay, so I want to see how far behind are we really. We don't often look at where we are. We don't compare in a technical way or looking at the numbers to see actually where are we. When you say we're behind, how far behind is that? So having a look at the subsea cables and capacity, I mean, we know that there's lots of activity happening with the subsea cables, right? Now in 2010, we had 30 cables coming to Africa, right? So this is across the whole continent. By 2022, which was last year, we doubled that, where we now have 60 cables coming to Africa from all over. Predicting, and if you add the planned cables that are still coming, we will have around 71 cable systems by 2025 connecting to Africa. That is crazy. That's a lot of cabling coming into the continent, going, taking us places, bringing content into the continent. So if we have a look at the graph, so if you look at the bandwidth growth by the region, you will see the first line there is Africa. So you can see our growth as Africa is way more than the other regions, except for the Middle East. So currently, us in the Middle East are kind of in this battle of developing the internet and the connectivity in our areas. Looking at the international capacity, so for the year of 2021, the overall internet capacity going through the continent in 2021 was 37.8 terabits of traffic. That's a lot, right? Looking back at 2017, which is 5 years ago, we were sitting at 7. So in the space of 5 years, all of a sudden there's like 30 terabits of traffic more in the continent. And again, looking at the investment coming in for the subsea cables, bringing in more content and creating that opportunity to connect Africa to more countries and regions. So again, if we look at the map, it looks fantastic. This is from Telegeography, the most recent and most updated map that they have. Currently, as of 2021, it is believed that there is over 1.3 million kilometers of subsea or submarine cables in service globally. Now, to put that in perspective, that is enough cable to go from here to the moon, twice around the moon and back. That's how much cables are in our oceans connecting us. There's a total of 450 submarine cables systems in service around the world, and some are quite short. So the shortest one being 131 kilometers, and that is between Ireland and the United Kingdom. Now, as we know, too, Africa is coming. It's making its way around Africa, and this will be the longest subsea cable to exist. So it's going to be 45,000 kilometers. It connects 33 countries from 3 continents. Now that is massive. And again, we in Africa, we are very excited for this, because what that means is with all the cables coming into Africa connecting us more, that brings down the cost of layer 2. As we know, there are many reasons why the layer 2 costs are so high in Africa, but we're hoping to see that with all these cables coming in and countries having more options on how to connect, it will bring down the cost as it's becoming a more competitive market. Prices continue to decline. Again, coming back to there's more options for countries or networks to connect this. No longer are you stuck with one carrier or subsea cable. So we've seen that the prices are going down. What we've seen is 100 gigabits wavelength prices decreased on an average of 12% between 2018 and 2021. That's compared to a 20% over the past 5 years. So already we can see over the past 5 years, it has decreased by 20%. Now imagine we just said that by 2025, there will be 71 cables connecting us. What does that mean? Like, how much more will the prices decrease? That's just going to bring more opportunity for connection and investment in Africa. The 2022 Digital Quality of Life Index, so this is a study on the quality of digital well-being across 117 countries, found that South Africa's internet quality remains the best in Africa. So well done, guys. We got there, we're on the list. So looking at, with a penetration rate of 51% of the total population of the country. So that means 51% of the whole of Africa is connected to the internet. So currently using it, whether it be by mobile, by laptop, by however, they are using the internet. So Nigeria is one of the leading countries, as we know, with the highest number of internet users. And interestingly enough, Egypt ranks second in the number of internet users. That personally I did not expect to see. The penetration rate of countries like South Africa, Kenya, and Tanzania is more than 30%. So we're there, but not really there. So we're getting there, guys. Now looking at some stats found from Afrinex, so if we have a look at the total ASNs that were available in the whole of Africa in 2013, there was 132. This is across the whole continent. We had 132 networks that had ASNs available to be able to peer at internet exchanges. Now looking at 2023, we have a total of 2,257 ASNs across the whole continent. So as you can see from 2013, it was kind of evenly spread where these ASNs are allocated to. By 2023, as you can see, some of the regions are a bit more darker, South Africa being the most dense in terms of the amount of ASNs allocated. And again, Nigeria also coming up, and we know Kenya as well. So there's still a good growth in allocations of ASNs. That means that there is a need to peer, to exchange traffic, and to bring more content to Africa. Now, I just want to point out how cute my little dinosaur is here, because he's growing. So looking at the capacity growth, the peering capacity growth, as mentioned, we just said that there has been a significant growth in the amount of ASNs that have been allocated in the past 10 years, and we anticipate to see more. Now, I'm not going to go into too much detail in all the other columns here, but I can just focus on Africa here. And what we can see is if we compare 2013 to 2023, there's over 1,000% growth in terms of members, so people peering, in terms of networks peering. So that is fantastic. I mean, what is that going to look like in the next 5 years? Again, going back to the amount of subsea cables coming in, the amount of networks investing in Africa, bringing POPs and edges and deployments to us. So it's very exciting to see this. Personally, I don't think it's going to be as significant, but it's going to be a steadily growth. Now, the average of internet download speeds in sub-Saharan Africa was highest in Rwanda, South Africa, and Madagascar, where in Rwanda it was 52.17 megabits per second, South Africa 28.62, so guys, you need to up your game. We need to get there. And then in Madagascar, 19.26 megabits per second. So very interesting stats, again, looking at the different countries. Then in terms of internet penetration, so we talked about Egypt and Nigeria having the most internet, or the highest internet penetration. Currently, South Sudan has 10.9%. and Somalia 13.7. So these are the two African countries with the lowest internet penetration rate. And then despite the rising number of users, the internet penetration rate for Africa as a whole is 43% in 2021, below the global average of 66%. So slowly we are getting to the global average, we are getting there. Morocco, so again, a statistic I did not expect to see is that Morocco has the highest internet penetration rate, reaching 88% penetration rate. That is fantastic. So that means 88% of Morocco's population has access to the internet. They are actually using it. So that is quite good. As of 2022, the share of the total population of South Africa using the internet was nearly 80%. So again, guys, we are getting there. So we're just behind Morocco in terms of the population having access to the internet. In 2021, roughly 13% of internet users worldwide were located in Africa. Now, 13% might not sound a lot, but looking at the amount of people globally, that's actually a lot of people connected to the internet. And again, it shows that we are not that far behind. We still have a good number of users in Africa. Now, what are the challenges? I mean, this gets discussed all the time, and it's well known. Currently, Africa is well known, very well known, for its unstable power supply, which, it has an impact on networks, data centers, and as well as the decision for big networks to put down their deployments, to deploy a POP, So this has become one of the most focused challenges in recent months, I would say, where we are focusing on how are we going to keep the internet running in this time of instability in power. Political restrictions. So I mean, each country has its own restrictions, rules, and policies around how to connect, where to connect, and how, when to do it. So Africa is well known for that, and that is also a big challenge. In earlier years where you had no choice, you could only use one carrier or only one network, you had no choice to do so. Higher layer 2 connectivity costs. So again, we mentioned this, it is quite expensive to connect in Africa, but hopefully with the subsea cables coming in, it's giving us a choice of where and how we want to connect. So we are anticipating to see that the costs will come down. As we mentioned, over the past 5 years, there was a 20% decrease, and we're hoping to see more as we go along. Poor infrastructure and the control that telecommunication operators have over consumer rates are among the leading causes of Africa's high data costs. This we know. It's expensive to have data. So again, there's a lot of initiatives and projects going on in the industry to try and get the data costs down. So with all of this said, I think we are not that far behind, and I think if you look at the numbers, we are there, we are getting there, and we are being noticed by other countries wanting to bring the internet to Africa. So in conclusion, please cut the internet dino some slack. He is doing the best he can to keep us connected. And that's it.
So as a lightning talk, we're running a little bit behind on the time, so if you have questions and comments, let's go ahead and catch her during lunch on that. Next up, I believe, is Mark.
John?
Yes.
Please use the microphone because people can't hear me.
Sorry about that. Next up will be Mark talking about ICANN DNS. And if you have questions for Yolandi, capture her during lunch, and I'm sure she'll be happy to answer those.
Cancun.
Cancun. Enter your Microsoft Office product key. Anybody have a PowerPoint file? don't think 1111111 will work. I know. Thank you, sir.
Let's not worry too much about that. So several weeks ago, I'm going to talk first of all about DNS training. DNS is the stuff I like, it's on my t-shirt. And then I'm going to talk a little bit about a study project that we're doing, again on DNS. So a couple of weeks ago, we had the first advanced DNS training courses in South Africa. We did a training session in Johannesburg, and we did a training session in Cape Town. So very brief summary of what happened. 2 trainers, Johan Stensom and myself, were involved in this. One of the unique things about this particular training course, it's not just death by PowerPoint, but there's a lot of hands-on stuff. Everyone has a network of machines, of about 5 machines, and these are all interconnected with everyone else's machines. And so it's a proper working live environment from a lab point of view. We actually have a number of people in the audience who actually went on this training course. Can I see a show of hands? There's about 4 of us. 1, 2, 3? 3 of us in the room. Okay, so it's a real training course. So because over the last several years, where we used to do the training course, we found that from a South African point of view, about 50% of all DNS lookups actually went through a recursive resolver. That's from studies done by APNIC. So we did quite well, but that's the simple bit. And when you install bind nowadays, that's pretty much the standard default. That works. Going further on to actually signing zones is a little bit more interesting, or in fact looking at DNS security and vulnerability. So on the one side we've got the primary and the secondary servers, and the relationship with that should be using something called TSIG to make sure that the data doesn't get modified. And I guess a number of internet service providers do that, using TSIG. If you're not doing TSIG, you should be doing TSIG. TSIG is really, really simple, and it works, and it can work extremely well. On the right-hand side of that, we've got the recursive and the stub resolvers. That's where DNSSEC proper comes into play, and DNSSEC can be slightly more challenging. So the advanced course goes into how you do DNSSEC. And with the changes that have been happening in bind recently, although it's also available in some other of the name server tools, there is a section called CASP, the key and signing policy. And this is rather cool now. You set up one stanza in your named.conf with a CASP, or the key and signing policy. You put your information into that, stating how long key signing keys and zone signing keys are going to be valid for, and bind basically does the work for you nowadays. You don't need to individually sign certificates and things like that anymore. So that's just the slide that talks about what CASP is. If we move on from there, and then you tell your particular zones to use the default signing policy, and it simply works, which is really, really quite cool. I suppose another big question that people ask is, well, what key algorithm should I be using to sign a domain with? We started out on algorithm 5. It's definitely somewhat depreciated. I eventually convinced doesn't matter. Eventually convinced not Nigeria, Namibia to change his key. He's been using algorithm 5 for an awful long time. He's now using algorithm 8. Algorithm 8 is what the root is currently signed with, and unfortunately fortunately what a lot of people now are using from an algorithm point of view. The problem with algorithm 8 is it generates quite long keys, which means it becomes a great target for DDoS attacks using DNS. So we're looking at elliptical curve, and my understanding from the vibes, listening to the experts in the room, is that ED25519 will probably be the preferred elliptical curve signing systems. So that's algorithm 15, I believe. So if you're going to look at signing with, and you're going to start with it, look at algorithm 15. It is fully supported by the local registries, so no problem there. And it seems to work fine, just some advice there. And changing algorithms is not the easiest things in the world, so start with a good one that gives you a good 5-10 years. Some of the other new things that have happened recently in the DNS environment is a new record type, the CDS key, or the child DS record. And basically that is what you would put into the parent, which is what you need to make sure the security of your zone is traceable, or when you do a recursive lookup, you look from the root downwards, and that is part of the chain of trust. So your DS record is the only time that you actually need to talk to your parent to put the DS record into the parent, in the same way that you put name servers into the parent. But there's a number of tools, or what a number of people are doing. If you're running a 2R registry, you should probably look at polling your own clients for CDS records. If you're a registrar and you're running DNSSEC and you're not running the domains themselves, but your customers are running their own name servers, then perhaps look at polling for CDS records that you then pick up and push to the parent. That would be rather a cool idea. And the course included some of the work there. And the other thing that was also spoken about was, well, what about name servers themselves? And that's where the C-Sync record comes into it. Again, there's lots of work on that. And if this is all too much for you, then we can move on to more things like security. You've got DNS over TLS, which is rather a cool way of securing your TLS, your DNS, so that lookups are then private, they're encrypted. Of course, you've got other things like DNS over HTTP. The guys running DNS over TLS, they spent years and years getting it right, etc. And then along comes Google, etc., and literally overnight implements DOH, but never mind. Anyway, that was the end of the first presentation, which was about training courses. The training courses are free. You pay a deposit, you get the deposit back when you actually pitch up and do the course. It's a 4-day course, and it really is hands-on. And some people really don't like doing the course because it really makes them think, is what I was told earlier on. And I'm now going to try and change slides. Can I have a hand? Yeah. Okay, so I'm also part of this project. Well, 7 years ago we ran this project, and we're rerunning this project. This is the ICANN DNS study of Africa. So we did the 2016, and we're now doing the 2022 version of this. So this is up and running, working at the moment. The 2016, we took like a year and a half to run it. Took a long time, never mind. We recently got awarded the tender right at the end of, halfway through December, basically the end of the year. Back then, .Africa never existed as a matter of interest, but since then Africa does exist, and so we've changed the name of the domain system that works that. Very briefly, that's the time scale that we're looking at the moment. So basically we've just done the one ICANN meeting, very interesting, first time to Mexico for myself. And then we have another 2 ICANN meetings, one in Washington, and then the last one in Hamburg. And we will be doing the full presentation of the results in Hamburg. So that's kind of the time scale. What's new since the last one? We've added data centers, although I'm sure we need more questions there. We've also added a couple of extra languages, and there's been various updates to questions and things. What I would like to ask the people in this room to do is to have a look at the URL dnsstudy.africa. Very easy from the contents of this talk, and log in there and answer the questions that are relevant to you. There are categories of questions. There are questions for registries, registrars, registrants, regulators, IXPs, data centers, and resellers as well. So there's stuff that covers everyone. If you find that you can't answer a question, or rather you can't get into a particular category, please talk to me and I'll open it up for you. And that is in my interest to get you guys to do. What else is different? This year looking at a country leader per country. I am the country leader along with William Stuckey for South Africa, hence me talking to you as well. And we've been doing a bunch of training. It's all very, very active, and some country leaders have even finished their tasks. If anyone happens to know people from Djibouti, Guinea, etc., please let me know, because we're still looking for volunteers for those countries, so I'll ignore that slide. And country leader jobs are actually pretty interesting. Collecting information from the registry, etc. What is also new about this particular study is we're going to be setting up, hopefully, the observatory. So we're going to be collecting data from an observatory, from CCTLDs in Africa. The reason why, well, one of the things that I run as well is edu.za. So there's some basic stats on edu.za which I properly collect, and what's pretty is that we can turn these into pretty graphs, and we can look at growth over time. We can look at how well the internet from a domain name point of view is increasing. To me this is kind of interesting. I like how not just the number of domains but the number of websites, and how many of those websites are secured by things like SSL certificates, etc. And that is the end of my presentation. So I believe I'm easy enough to find if you have a problem. Thank you very much. Questions later.
Thank you,
You're
Mark.
doing that.
If anybody has questions for Mark, catch Mark, as he said, he's easy to find. And our last lightning talk presenter is Magical Ed.
I'm going to try to be super quick since, well...
Not that quick.
Okay, we'll just sort out mics first, sorry. Because we are running slightly behind time. Let's just get to my preso. So this is not my actual presentation. It is one from a work group that I'm part of the ISPA work group for sort of fiber ISPs. It's something that's become a bit of more of a noisy thing lately, since there's been lots of changes in the industry and people have decided, well, they need to work together. So one of the things that's come up is there was a decision made that the ISPs want to do sort of generalized ratings of the various FNOs. So there's, oh, it's not displaying. Oops, sorry. That helps. Sorry.
there's a link to a quick survey. It'll probably take you 15 to 20 minutes to fill in. This is only if you're an ISP that sells services on another F&O. It's been discussed at the Fiber ISP workgroup for ISPA and to WAPA. Please, only one response per ISP. If there's a conflict of interest, like you work for, say, the company that owns the F&O, please don't do feedback on that F&O itself, because that just skews some data. And then we'll only sort of publish aggregated insights. So we're not going to say like, oh, Bob said that F&O1 is a pile of horse poo. So there's a lot of F&Os on there. We try to just stick to the major big ones. There might be some smaller ones. If there's one you think needs to be there, you're welcome to reach out to myself or any of the other Fiber ISP workgroup members, and we can quickly get it added. It's a couple of simple questions like value for money, reliability, how well their support works. There's currently about 25 ISPs that have responded to or filled in some of this. So we're just trying to get that data set quite a bit bigger. And yeah, for this group, the most interesting aspect is whether it's open access and how, if they really are open access, or if it's a ISP that we know mess with other people. And then the idea of this is so that we can help improve the general landscape. Yeah, we're aiming for about 50 responses. As I said, we're happy to expand the list. And we might repeat the survey if it seemed useful. And then the deadline for this is next week, Wednesday. So if you can, please just fill in that, take a photo of it, or if you can't photo that, just kick me or email the ISPA secretariat and we can get that link to you. So yeah, thank you very much.
Thank you, Ed. Next up, we are going to be talking about DNS hygiene. And this will be Amrish. Let's see. ZANOG DNS hygiene.
Yes. Good.
Okay.
Oh, we need to do mirror, right? Mirror. Excellent, thank you. Yes.
Great. This is the toughest time of the day because I'm between you and lunch and I'm stopping myself. Try to be quick. All right. Yeah, this talk is about DNS hygiene. I think we have talked a little bit about routing hygiene yesterday with RPKI and everything. But as you know, DNS is also a very important component of the internet, and there are best practices out there that it would be good that operators follow. So do you know your hygiene? Do you know your DNS hygiene? So I was looking at Shadow Server, which is an organization that collects data on the DNS, or about the DNS, and managed to pull some statistics from South Africa, the number of reported unique IPs under which there is an open DNS resolver is around 13,000 and basically ranking third in Africa. John talked about DDoS attacks yesterday, and DNS open resolvers can be a source of DDoS attacks. So I guess there are things to do to improve hygiene generally. There's another source of information, Cybergreen. They also run internet-wide scan, and in this case they are showing the count of vulnerable devices. So it's around 30,000 vulnerable devices that were detected in South Africa, but there are some quite weird spikes in January. I don't know what's happening, going up to 400,000 vulnerable devices where an open recursive DNS was actually detected. So if you go on that website, cybergreen.net, and you select South Africa, you can even look whether your ASN has any vulnerable devices. All right, so this brings me to a topic that I would like to bring on here, which is called kindness. So what happens is that on DNS, obviously there are best practices that we would like operators to follow. They are documented in many places, in some of them in RFCs, some of them in best current practice document, BCOP documents. But I believe there isn't like a single place where those best practices were documented. And this is how I guess ICANN came up with the kindness platform. I think they were inspired as well by the manners platform, which is also another best current practice type of framework where we encourage network operators to adopt a few best practices and actions for them to secure their network. And in this case, it's the same. They are targeting authoritative DNS operators, secondary level DNS operators, and also resolver operators. So let's start with the authoritative DNS operators. What are they recommending? They're recommending that obviously the zone that the authoritative DNS operators is managing must be DNSSEC signed, and obviously the keys that are being used to manage or to sign the zone should be managed in a proper way, like roll over periodically, etc. There shouldn't be transfers between authoritative servers, because an authoritative server should manage a single zone as much as possible. The zone itself should be protected against tampering, so the integrity must be controlled. The authoritative and recursive name servers, as you know, there is authoritative and recursive. They must run on separate infrastructure. It happens, I think, in the past where, for example, you would install Bind and you could actually get both authoritative and recursive on the same system. Usually it was helping people to spin off quickly a DNS server, but the recommendation here is that to split both and have them on separate infrastructure. It is recommended to have at least two name servers for a zone, and as much as possible, the two name servers should be on two different, or on a diversity of network. The diversity means different networks, different ASNs in different geographical places, and if possible also to have different software running those name servers. So a lot of, we have seen now a lot of TLDs or their name servers or Anycast, so which is great, which add a lot of redundancy. And finally, monitoring. No need to tell you that for any critical service that you run, you need to monitor the service. So these are the set of recommendations. They go on for the authoritative, but they have the same, almost the same for the secondary level. And then they have a set of recommendations for the resolvers. For example, you must do DNSSEC validation, so on and so forth. But what can we actually measure? Because a lot of those practices that they mention out, not all of them we can measure. We can only measure those that we have access to. For example, open resolvers, we can detect them in the wild. We can also know what are the authoritative name servers, because these information are out publicly. So these are the places where we can actually run measurements. So again, what can we measure? DNSSEC adoption is something that we can measure using active scans, research projects such as OpenIntel and Rapid7. They also provide very good statistics. Geographical, topological diversity, all these can also be detected usually using active scan. QNAME minimization, which is an important mechanism for privacy. It should be implemented by resolvers. Can also be detected using passive and active scans. So, as you can see, a few of those components can be detected using measurements. And some statistics, these are not mine, they are coming from a paper that was published last year. So out of 638,000 IPs that were detected, 52% of them have a web port open. So if you are running a DNS name server, you shouldn't have a web port open on a DNS name server. Around 40% have a mail port open, 31% have an SSH port open, and they found other popular ports such as FTP, Windows Share, etc. More now on recursive resolvers. About 1.6 million resolvers that were detected. 8% have web ports open, 6% have SSH port open, and 5% have telnet ports open, on top of having other services which shouldn't be there normally. And there we also found in that list of practices that are actually provided or recommended by ICANN, that a few of them obviously are difficult to measure. Monitoring, because this is internal to your network. ACL, what are the ACL filters that you put to allow access, for example, only to your customers? We cannot know that. Whether you are using, which authentication systems are you using for SSH, and what type of hardening are you doing on your server, etc. These are things that we cannot measure because it's internal to your system. And also we found that if you imported things that are actually being in use in the DNS ecosystem are not being measured here, are not being even considered as a best practice. For example, any cost deployment for critical zone, we haven't found anything mentioned in the kindness design DNS provider diversity. Remember the DIN 2016 incident. So these are things that we could look at. Caching best practices, having long TTL values could increase resilience against DDoS attack, and also preventing lame delegations. This can be of an issue, for example, increasing DNS resolution time on the internet. I used references from these papers that was published last year at a measurement conference, and that's it. That was quite short, I believe. Thank you.
Great. Anybody have any questions or comments? All right, well, thank you very much.
Cool. Thank you.
And with that, I believe we have lunch. Ed, do you know where lunch is today? Boma. It's in the Boma. All right, so everybody knows where Boma is? Out the door, go left. Cool.
Perhaps this will be short, but again, once I start talking, if I decide I'm going to go down some rabbit holes, maybe I will take the whole 25 minutes. I'm just going to talk about some of the ways that we would like to see ISPs using or kind of creating new architectures with DNS recursive resolvers and forwarders, and also some hints just for ISPs as far as what we've seen in the DNS environment.
Privilege to introduce a friend of mine, John Todd, and he's going to be talking about future-proofing ISP DNS recursive resolvers. Hello, John. Can we hear you through the magic of technology?
I hope so.
Awesome.
Great. Thank you for having me, and welcome back from lunch, everyone. I'm sorry that I could not be there in person. I wish that I was sitting there with a coffee myself. So my name is John Todd. I'm the general manager for Quad9, which is a recursive resolver operator based in Switzerland. At the moment, however, I'm based in North America. So my apologies for the frogs in the background. It's quite early in the morning here, and they may be making themselves known outside my window. What I want to do today is talk a little bit about sort of the concept of future-proofing ISP DNS recursive resolvers. Those are things that most ISPs or network providers offer in some fashion. And I'm going to take my Quad9 hat off partially because I want to talk to you about not what Quad9 does on the recursive side, meaning in our global configuration, but really what we get questions about from small, medium, and even actually some large ISPs about how to integrate with our system, but also how to create a robust DNS architecture in general. So you'll hear me talk about a little bit about technology, but also about some other kind of policy level things here that for ISP recursive resolvers need to be thought about for both today and now in the coming future. So the first thing is that DNS is one of those fundamental components of a network that is always or never to blame, depending on how you are looking at it from where in the network you're looking at it. So it's really important to do DNS correctly and get it done robustly. DNS, most of the time, has been something that's kind of a second thought for network providers, but it's becoming something that you have to think about quite a bit more as it's becoming more complicated here in the last 4 or 5 years, really. So what are the features as a network service provider that you should offer? And we say you should offer these because we see, of course, a strong demand for this from Quad9's perspective, but it's things that people are more talking about these days. What are the best common practices and the standards that are becoming kind of table stakes for operating a recursive resolver inside of your network? So the Quad9, of course, focuses on both security and privacy. So we'll talk about privacy in a couple different ways. High privacy externally means don't leak your private data, don't leak PII outside of your network. And so that's meaning queries associated with IP addresses, you probably don't want to have distributed outside of your network. That's becoming much more concerning data. No one has really treated DNS queries themselves as PII, but certainly IP addresses associated with queries are. So especially in Europe and North America, that's becoming more critical, but that's going to spread internationally as well. And then high privacy internally, what's your privacy policy as far as what you do, what you say you do with your DNS data? And I'll talk a little bit more about that later in the deck. Then from a technical perspective, what you should offer, and of course fast response, you want to have quick responses on DNS, so cached answers are something that you're really looking to give as much as you can. Encryption has been around now for quite some time. We were one of the first resolvers to operate with DOT or DNS over TLS back in 2017. That's now becoming very standard, as well as DNS over HTTPS. Emerging standards of DNS over QUIC is coming soon, and we're seeing rapid adoption of that by client software manufacturers, browser manufacturers, operating system manufacturers. So the transition to encryption is happening, and as a resolver operator, you probably should be offering that, or you'll be left behind. DNSSEC strict out validation. DNSSEC to validate and make sure that the answers getting from authoritative servers out on the internet are in fact true. DNSSEC historically has had a lot of detractors because it's problematic or has been problematic, but that really hasn't been the case in the last few years. Quad9 has been operating strictly validating DNSSEC infrastructure since we started in 2017. We very rarely get complaints now, and we have tens of millions of users in every nation in the world almost at this point. DNSSEC is no longer something that you should not And lastly, and actually most importantly, is value-added services. Are you using the DNS for anything else? Do your end users find value in what you're doing with the DNS? Do you offer some kind of malware, anti-phishing service? Do you block ads? Is there something else that you're doing with the DNS that makes people want to use your service versus trying to go over the top and use some outside service like something like Quad9 or any of the other advertising free services that block ads, for example? So let's go through what DNS has looked like traditionally, and then we'll talk about what we see or as a potential suggestion for ISPs is a better way to do it. So do it yourself, right? Run a resolver inside your network. Your resolvers talk to your users talk to the resolver. There's a cache in it, and then the resolver talks out to the internet. This is kind of the DIY version that's been done for a very long time. Most operators are familiar with this model. It keeps your traffic local, meaning that your resolver is inside your network. Your cached answers are very close to your end users. It allows you to have some flexibility and add some additional features into your resolver if you've got the skills to do it. The cons are there that it's no longer as trivial as it used to be if you're doing encryption. There are some costs to the software to manage and maintain. The value add, you then have to figure out how you're going to do that value add. What is it you're going to provide and how much is that going to cost you if you're going to do those yourself. And then, of course, somebody needs to own the services in your technical team. There's another model of doing recursive DNS where you essentially outsource your DNS directly, where you send your customers or your end users directly to a global recursive resolver. In this instance, I'm going to use 9.9.9.9 because I'm Quad9, but you can substitute any other global resolver in there. This avoids any of the costs or hassles of running your own infrastructure, but you lose pretty much all of the control. It's extremely easy and it's extremely cheap. You don't have to have any hardware, but you don't have any control and you don't have any ability to offer any value add other than what gets sent out to that global resolver. If you're going to pay that global resolver operator, as an example, if they try to sell you some upgraded package of some sort like anti-malware, you can do it that way. It's slower because you're automatically sending your traffic off net. There are no locally cached responses, so it's not as particularly fast as it could be. And then there's DNS forwarding is another model where you have a forwarder, which is really something like Bind or PowerDNS or any of the other operations software, and you forward the queries out to a global resolver. That's easy-ish. You still have to implement the software. You still have to have a server there to do that. It's not particularly robust. You're actually introducing more points of failure. So if the global resolver fails, you've got an issue. If your equipment fails, you have an issue. And it's typically not dynamically reconfigurable unless you have a cluster of them in some kind of anycast mode. I'd like to introduce maybe a new model of doing it that many of you might consider, and that is using DNS dist as a robust hybrid approach. So this is the model that we suggest, or that could be suggested as a way to do this. Your users are going to go talk to a software package called DNS dist. DNS dist is really a shim. It is not a recursive resolver, meaning it doesn't actually answer queries, but it has a cache. It has a development language for doing policy and a bunch of other things. And then you would also have a local resolver inside your network with a low priority. And then you would send all of your queries out to a global resolver at a high priority. So this would allow you to still get the benefits of the large global resolver for most of your queries and to cache them inside your network. But yet, if you have a problem with the network, or there's a problem with the global resolver, or there's a problem somewhere in the stack outside of your control, you can still fail over to the local resolver inside your network. So this model allows you to have both the benefits of the local resolver, but also have the ability to do the outsourcing to the global resolver for some of those value adds. It also increases the speed because typically the global resolver is going to be faster than you are in some of these responses because they have a larger cache community. There's also an interesting ability for you to add a lot more flexibility and interesting tools inside of DNS dist. I'm sorry if I'm sounding like a DNS dist salesperson here. It's an open source package. We use it inside of Quad9. It's amazingly flexible. It is extremely robust. We have very almost never, I shouldn't say never, but almost never have crashes, and we serve tens of billions, hundreds of billions of queries on this platform without any difficulty. However, it still requires that you have hardware in site or on site. It still does require someone on your staff to understand it, so it doesn't avoid the complexity of owning the service yourself, but it gives you a lot of upsides. So DNS-Dist is sort of a universal toolkit for advanced DNS. Anybody who's doing anything sophisticated with DNS services should really look at and understand DNS-Dist. It sits in front of a recursive resolver like bind, unbound, but also in front of other providers like Quad9, Google, Cloudflare, or others. So you can stack these benefits. So DNS-Dist will do encryption, so it will support DOH and DOT. It will actually forward out with encryption. It has a packet cache, so it's super fast, and it supports some other interesting features. I can't go into all of them here, but you should really take a look at DNS-Dist and see what it can do for you in this hybrid model where there's a local resolver in your network, but you're sending your queries out to a global resolver. It gets you that robustness and that ability to add features very quickly. So forwarding your queries out to a global provider, why would you do that? Like, in other words, why would you not just incorporate all of this inside your own network? There's actually some pretty good reasons for that. The DNS right now is getting more complicated with encryption, with some of the new standards coming out for privacy, et cetera. Why not have somebody else do that for you if you can rather? So outsourcing some of that work to a global resolver does actually sometimes make sense. It's high reliability. We operate with a lot of nines, obviously, Quad 9, but we operate with a lot of nines for reliability. The only time that that's a problem typically is when there's a network issue between the provider and the outsourced global resolver. That's why you have that failover backup inside your own network that you can kick back to automatically with DNS-Dist. But other reasons to use an outsourced or to use the global resolver are larger communities mean faster caches, meaning that those answers are probably already in the cache. Also, larger communities means a bigger crowd, and that means more privacy. No one can identify where queries are coming from because there's a larger set of noise into which your queries are going to be inserted. And those global resolver operators are probably spending a lot of time focused on DNS, whereas maybe this is not the primary job of your team. So they'll be able to catch problems and solve problems before maybe you even see them. Lastly, and most importantly, some of these larger operators provide value-added services like the anti-malware, anti-phishing security service, which Quad9 does as an example. And if you can get that for free, why wouldn't you use that as a primary resource? In other words, send all your queries through someone in Quad9, where you can get that added benefit at no cost. So how do you pick the global recursive resolver? Well, of course, we're biased towards Quad9 because we're a nonprofit. We don't get any money from any of this. Our job and our mission is to provide security and privacy. But there are others out there. There are some that provide different services than we do. You probably want to look closely at the privacy policy and see, what is being done with that data. How is it being applied? But also, you want to look at some of the technical components of it as well. Latency, like how far is it between your DNS-Dist instance, which is going to be doing that packet cache, and the global recursive resolver? What's the latency? The speed is important, but it's not as critical as many make it out to be. 10 milliseconds is probably going to be okay. In fact, even more than that is usually not noticeable by end users. You want to do that test yourself, but there's a lot of people who are making 1 or 2 milliseconds into a big deal. It really isn't with DNS because DNS queries are typically done in parallel, so it's not like you're stacking that delay. Where is the resolver cluster? Is it nearby? Is it in the same country as you are, or are you sending your queries across the borders? If you are sending queries across national borders, do they support encryption? If they do support encryption, how does that work? Test it out. And what's the value add? What are the things they're trying to add to the service? Is it something like ad blocking? Is it malware blocking, et cetera? And then is the global resolver operator aligned with your interests? These are questions that you can answer just by doing some quick research. Quad9 doesn't want your queries. The whole reason for me giving this talk is that I would love to see every ISP in the world using a forwarder and a failover backup in this model. Lots of ISPs do send us queries directly from their end users. We would love to not see the IP addresses of your end users. We would love to see just a single IP address of your forwarding, whether that's DNS dist or it's a forwarder, because that improves the customer experience for your end users. It improves privacy. It removes that toxic component of personal data, meaning the IP address. It doesn't expose that to the rest of the network. And then lastly, of course, it reduces the load. We would love to see caching being pushed closer to the edge of the network as far as we can, but still being able to give people that benefit of the security, meaning the anti-malware, anti-phishing, and also the privacy. Other things that are kind of table stakes now for DNS is adaptive DNS discovery. This is an interesting one that once you've got something like DNS dist in your network where your users are pointing at DNS dist, you can enable this relatively quickly. This means how do you automatically turn a user from just a standard UDP unencrypted user into an encrypted DOT or DOH user? And adaptive DNS discovery is now being adopted by many vendors. Mobile devices, Android and iOS are now supporting this, and Windows and macOS, I think, are in queue right now. Really, it comes down to being able to answer a static response. You can see in my slide there, DNS_DNS.resolver.ARPA type 64. The first time the device comes onto the network, it will actually ask for that from the local resolver, and it will try to get an answer back. And you can see this is the configuration language, the Lua configuration language here. This is how simple it is in DNS dist, is to provide back a specific answer. Clients that get an answer that is valid will try to upgrade to encryption. So here's what this actually looks like from a DNS dig perspective. This is what Quad 9 looks like, but you can get an idea of how you would do it on your own network. If you do a query of this type, you're going to get what's called an SVCB, or that's type 64. You get back two answers if you ask Quad 9, and we give back our IP addresses, and then we give back also the names of dns.quad9.net. So this would cause the client to automatically try to upgrade to a DOT or DNS over TLS connection first. They would have to basically get the correct cert, and the cert has to have both the IP address and the name in it. But then they would automatically upgrade to encryption. Encrypted DNS is something that people are asking for now quite a bit. So this would allow you to automatically upgrade devices in your network to encryption with your resolver as the destination rather than some resolver off network. So some other bonus features you get with DNS dist is you get a lot of monitoring. Once you've enabled DNS dist, there are, I think, 100 and some odd monitoring elements you get, which is fascinating information, because the DNS is so core to everything that we find that being able to visibly view DNS trends on DNS dist will illuminate other things in your network that you didn't even know were going on. And I put an example of here, looking at serve fails coming from your local resolvers or from DNS dist. Sometimes will illuminate the fact that you are no longer able to reach via BGP certain destinations and authoritatives, or slowdowns in your network. You'll be able to actually see in the DNS rather than having to look at other protocols. Of course, it doesn't substitute for good monitoring in other areas, but when the network is sick, DNS sneezes is the term I use, and you can see some of these failures by looking simply at the DNS data with something like Prometheus and Grafana, which DNS dist makes very easy to implement. So general DNS experience notes, and I said I'd talk a little bit more about privacy policies, and so this is something not at a technical level, but if you're future-proofing your DNS resolver, you really need to look at privacy, because this is becoming a critical issue. Do you have a privacy policy for your DNS services in particular? Are they specifically called out either as a separate document, or are they spoken about in your general privacy document as far as what you do with DNS queries and how you treat DNS as a separate class of information? You probably should consider this. It's relatively easy to build a document for DNS privacy, and customers will typically feel much more comfortable if they know what you're doing with DNS data and that they know their privacy is not being violated. There's actually an RFC now for it, RFC 8932, which is a great resource to start with. There's actually even a prototype privacy policy at the very end of that RFC, which you can cut and paste and edit to your satisfaction. Also, there are some initiatives like the European Resolver Policy.com, which has which a number of different both global resolvers as well as telcos have put some input into, which kind of give a best common practice for DNS privacy and DNS data management. Don't be caught unaware of this. DNS privacy is becoming a question of legislative concern, so having these documents ready now or having it already taken care of will hopefully try to eliminate some of those issues for you if suddenly national policy changes or if you have to work across borders. Other experience sharing that I'd like to give you is just kind of give you an idea of some of the things you need to be prepared for. Encrypted traffic is quite a bit heavier than unencrypted UDP. So you may experience up to 5 to 10 times more processing power or memory than UDP. Hopefully that number is going to come down over time, especially with some of the new technologies which leverage better stack incorporation for different encryption protocols. But it is heavier, quite a bit heavier, so be aware that that's the case. But still, DNS as a protocol is relatively lightweight and small, so it's not like you're looking at lots of machines to do this, even for a user community of tens or hundreds of thousands of users. It's still not massive. It's not like web traffic is. DNS dist, again, has rate limiting for clients. We found that people who implement some sort of rate limiting or rate visibility will find interesting and surprising abuse patterns inside their network, where clients are asking for 1,000 queries a second for the same name, or people are running some kind of botnet inside their network that's doing abusive behaviors. You should probably look again at DNS dist. It has some very interesting rate limiting and rate management tools in there, and you'll find abuse where you didn't know you had it. Lastly, ECS or eDNS client subnet is not as effective as you think it should be, and this basically comes down to, again, picking a global provider that has good geolocation that is close to you. If you're picking so ECS basically means if you're getting DNS answers that are good inside of your own country or inside of your own ISP. So make sure that whoever you look at from a global services perspective is as close to you as possible. Last on my list of interesting things that are about to happen is recursive to authoritative encryption. We've sort of solved the problem of client to recursive resolver encryption. We've got we've really got 3 different protocols: DNS over TLS, DNS over HTTPS, and there's also DNS crypt, which is less used, but that's unfortunate. It's actually a pretty good protocol, but it's the third runner. But that solves the client to the recursive resolver. Really now what's missing is the recursive to authoritative. That is happening slowly. There have been some tests already done where we're looking at some authoritative servers are running on port 853, which is DNS over TLS. And it's opportunistic where the recursive resolver will talk to the authoritative and try to actually create an encrypted connection. So in tests that look to be about, I think the number was around 7 or 8% of the query data was actually able to be encrypted if that was turned on. So that's very interesting. But that's coming soon, when the standards are not quite done for that yet, but I think that that's going to happen relatively quickly. Right now, PowerDNS recursive resolver is the only one to support that, but I suspect that Unbound, Bind, Not, and others will jump on the bandwagon probably within the next year, but that's a guess, to support that encryption. So this would encrypt the entire transaction of DNS, which is great. It's really the last unencrypted protocol that's finally seeing full armor being applied to it across the board. So I'm pretty much coming to the end of my discussion. I'm hopefully opening up for questions as far as anything specific to Quad 9 or the architecture I've described. Happy to answer them. Also happy to answer questions via email if you've got them.
Thank you, John. We've got some time. If anyone has some questions or comments, please come up to the microphones, and again, reminder, state your name and affiliation. Thank you.
Hi, John. Can you hear me?
I can.
Super. My name is Amrish from the Internet Society. So my first question is, I understood DNS dist does some amount of caching. So how does this work with the caching which is already existing on the resolver?
It actually works in conjunction with it. So DNS dist uses what's called a packet cache, which is slightly different than a regular cache on a resolver. but it performs essentially the same function. It is a layer in front of the recursive resolver, so it removes the load from the recursive resolver, whether that's going out to the global resolver or whether it's your local recursive resolver. So those queries never make it to the recursive resolver, which is actually very good because you want to try to separate that out as much as you can. Recursive resolution takes a lot more energy than simply cache answering. So it's as if you're taking the cache from the recursive resolver and putting it into a separate process, potentially into a separate machine. And it is actually a little bit faster even than the recursive resolver caches that exist in most recursive platforms.
All right, thank you. And maybe a second question. So how do you protect the communication between the DNS and the resolvers? Is there encryption in between those two?
Yeah, great question. Actually, yes, there is. DNS-dist supports not only encryption terminating from the end users, but DNS-dist will actually send requests out to the upstream resolvers, whether that's the resolver in your network or whether it's a global resolver. It can actually support DNS over HTTPS and DNS over TLS on the outbound side as well. So it itself looks like a client, which is great because you can also pipeline your queries over a single socket instead of creating a bunch of different sockets. So it supports both inbound encryption termination and outbound encryption origination requests to resolvers or upstreams.
All right, thank you.
More quick questions. Hi, Todd. Graham here. I suppose. I'm a big fan of Quad 9. I use a lot for my personal stuff, and the architecture you've described with the DNS disk in front of a Quad 9, I've also got that deployed in a few places where it makes sense because the load is low but high, kind of quite important that it's reliable within some management environments that I run. My concern is that with a different hat on, I've got a big ISP customer base, and there's still a number of CDNs that are using the source of the DNS or the IP of the DNS resolver to identify how they map traffic. And I'm sitting with this quandary of Quad 9's great, but am I going to break things when I'm dealing with a massive customer base? Am I going to break CDN traffic?
Yep, so there's two interesting answers to that. The first is that Quad 9 actually does support ECS, meaning that you can tag outbound queries with the /24 or the /56 or whatever you want of the originating IP address. And we will respect that, meaning we will take that tag and we will pass it on to the authoritative server. So that's ECS in a nutshell. Basically, it's somewhat privacy violating, meaning you're passing something about the end user out through the query stream to the authoritative server. So we support that. 99911 actually supports ECS, but you have to intentionally pick that IP address. So that's one path. The second path is that the model I described where you put DNS-dist in your platform and you have your own recursive resolver. DNS-dist supports some really interesting policy tools that are pretty easy to implement. You could find, as an example, the domains that are specifically causing you problems, and you could originate the queries to those authoritative servers from your recursive resolver, meaning the IP address would be the origination inside of your ASN, and would be an IP address that you own and operate. So there's a couple ways to slice it.
All right, great. Ed, did you want to? Awesome. All right, anybody else? Well, John, thank you very much for coming in. We really appreciate having you here at ZANOG, and informative presentation. Thank you, everybody. All right, well, that brings us up next to 21st century data centers, and my pleasure to introduce Martin.
Put this in your pocket. Just put it on. There's a mobile in there. Better take that out first. It's better. Thank you. That's the one.
this one?
Yeah. Why are there two?
Well, one's a PDF and one's a PowerPoint.
Okay, we'll do the PowerPoint. Thank you. Yeah. Lovely. Thank you.
There you go.
Lovely. Thank you. Martin Atkinson of Equinix Inc. It's very great to be here. Thank you for the warm welcome and everyone that I've met. It's been a great pleasure, and what a wonderful place this is. So I was asked to speak about 21st century data centers, and it's a bit like talking about fruit. You know, I mean, where do you start? There's so many different varieties. There's no one thing, a data center. And I just pulled this image up for the cover here, just to say, you know, more than space and power, yes, it can even be a boat. That particular project never really gained any traction, maybe thankfully. But this is really just an Equinix perspective on what we've been doing. That's more than just space and power. In fact, we use the term internally with a certain amount of derogatory implication that if we're just selling space and power, where we're coming from, that's us doing a bad job. So this is the only slide I think I've got about space and power, which I'll just, because it's maybe of interest, maybe not. There are now about 247 data centers in 71 metros around the world, covering most places where we can be, and Africa for us will obviously from next year, South Africa for us from next year will be an additional location. We are now currently in West Africa in Lagos, Cote d'Ivoire and Ghana by virtue of acquiring Main One. But the data centers themselves come in various shapes and sizes, as you can see. The design has been constantly experimented with and improved over the years, and we continue to work on that, primarily to drive down PUE, to drive up power density, and to meet sustainability targets as well. So really that's just kind of talking about what we've got. And as I say, there are 247. For those who might be interested, this is an artist's impression of the data center which is currently being built in Johannesburg. The initial phase will be 4 megawatts. We can go up to 20 megawatts over time with nearly 3,500 cabinets. What else do I say about it? It's very much a standard Equinix design. Standard PUE will be somewhere around 1.4. Maybe lower until I've got the full spec. I can't be completely precise about that. The whole Equinix model is very akin to what Terraco has done so marvelously well in South Africa, and that is as an interconnection hub, fostering particularly and serving particularly the internet community, and nurturing interconnection. So network density and interconnection are really, that's kind of the forte for Equinix, rather than wholesale co-location facilities or enterprise hosting. We don't offer any form of managed services. It's all about interconnecting people, but also in facilitating various types of service. So you see on the screen there, we've got Equinix Fabric, which we will be bringing with us. We'll be hosting at least one of the local IXs, Jinx. Then also attached to Equinix Fabric is Network Edge. We won't initially launch with Equinix Metal, but I'll talk a little bit about that in a while. And then Equinix Internet Access, which is basically us reselling a blend of multi-homed internet to a number of upstream providers that will be providing us with internet access. So I can move on from there, I think. Very, very briefly about Equinix. I've got a ridiculous amount of slides, by the way. There's way too many in here, so I've got about a minute for each slide, so I mustn't dally, I'm sorry. We started in 1998 with our first data center, and it was very much about carrier-neutral facility, internet exchange, supporting peering, and the growth of the internet in the early 2000s. And that continued really until, as a company, we started to pivot somewhere around 2012 2013, not away from internet services, but adding another layer on top, which was focused on cloud, obviously, which is now a big thing for everyone, but also enterprise IT support in a broader sense. And this is where the Equinix fabric comes into play. We're now kind of providing what we describe as digital services and digital infrastructure building blocks for a very, very broad set of sometimes next generation services. I heard Michael earlier was talking about 5G, and MEC in particular, and control plane, user plane separation for things like automotive, and that is an area of focus for Equinix at the current time. But we'll talk some more about that in a moment. So firstly, this is just a way that I prefer to talk about internet services as the B2C component of the digital economy. I don't know if it's something that other people like to talk about in that way, but I've come to realize that it is the main channel by which people communicate with end users, branches, etc., in increasingly connected vehicles, plant, etc. That isn't going to go away, and the internet's demand for internet services is just going to continue ad infinitum. I show this picture really, I call it the internet iceberg, purely because there's a lot of focus on IX, which is an absolutely essential component of peering and the internet services, but we should never forget private peering as well, because of the fat pipes. And so 90% of traffic flows generally is on PNI, 10% is on IX. So the model itself for internet services is, all three components, transit, private peering and public peering, have to be available, freely available, from a number of competitive providers inside the facilities to both optimize experience and costs to the providers that are delivering the services, such as content originators, etc. So obviously Equinix, having a lot of data centers in a lot of places, we've ended up with a lot of ISPs and also with a lot of cloud and IT services providers worldwide. But it really doesn't matter about the numbers, it's the same principle at work, at play across the globe. And in some respects, I see plenty of signs that, as well as South Africa, other nations in Africa will do very fast catch-up over the coming years. And this is just interesting. The reason that I'm focused on this is because from Equinix's perspective, we meet with all kinds of different regulatory and competitive environments, everything from total incumbent monopolies, where one or two PTTs rule the roost, and regulators are related in some way to the carriers, to completely deregulated markets that we in the West and also here in South Africa to some extent we're all used to. But it isn't necessarily the norm, as I know you're all aware. But what it translates into in terms of interconnection growth is shown on this slide. On the left-hand side, as we look at it, is the revenue. From two different metros across the globe. One which is totally was positively regulated. It's not completely deregulated, but it's positively regulated, if that makes sense, to nurture full competition between various upstreams and also downstreams for the content origins which we host, as opposed to the very, very low slope at the bottom there, which is an incumbent tied data center. The reason I'm showing these is not because they're kind of figurative. The numbers are removed for confidentiality, but in terms of the actual slope of those graphs is charted from two Equinix metros, one where we have a huge problem with incumbents controlling who comes into the data center through pricing strategy, and the other one which is truly open and neutral. And unfortunately, as a carrier neutral facility, we are very much at the mercy of incumbents where there isn't enough competitive choice in the market. So I thought it would be good to just show this, as this is a genuine experience of what we see as Equinix in some locations. I'm pretty confident we won't see it in South Africa, but parts of the Middle East particularly are a real challenge on that. So this is just an indication of how it works. and I'm not going to dwell on it very long, but basically any access points, either downstream or upstream, are over-monetized, and that keeps competition out. And that really is the death knell of the digital economy, as well as obviously suppressing interconnection growth. That's on the public B2C side, if you will, internet services and service delivery. On the private side, business-to-business interconnection and digital infrastructure, which is kind of where Equinix has pivoted to from about 2014-15 onwards. We've built this kind of thing called Equinix Fabric. I originally joined Equinix in 2011 as a concierge for Equinix Cloud Exchange, as Equinix Carrier Ethernet Exchange, which was a complete dead donkey because most carriers don't want a data center operator to build their NNIs for them, which I could have told them, but thankfully they gave me a job. And after they decided that that project wasn't going to work, they morphed it into Cloud Exchange. Then the acquisition of Telecity Group led to us actually having WAN links to clouds remotely and then connecting the various nodes together. And although it was very much an existential crisis for Equinix, through fear of competing with carriers, we went ahead and did it in the end. And basically what we've done is we procured MPLS wholesale bandwidth from our carrier customers / partners, who then provide the underlying bandwidth, and we have an SDN platform that manages layer 2 circuits from 50 meg up to 10 gig over the MPLS infrastructure, and then our procurement team just manages the contention ratios and procures the additional capacity as needed on the MPLS links, and purchases additional diverse links as and when required to maintain adequate redundancy. Last week, I believe we turned up circuits from Dubai, which was a big cause for celebration for us because it's been very difficult to get the incumbents to agree to us procuring wholesale from them to actually then deliver this agile layer 2 SDN service over the top, which they cannot provide anyway because they don't have the facility to do it. So at least now everyone's happy, and we'll see how that goes. So although Dubai isn't shown connected here, it is now connected into somewhere weird like Genoa and Milan, I believe. Geneva and Milan. But it's hopefully the start of a very happy success story. Lagos also will, over time, be connected. And obviously, when we launch here in Johannesburg, we'll be procuring wholesale bandwidth on some of your networks to run the MPLS services that will support Equinix Fabric virtual circuits into Europe and across the rest of the world. Most of the locations, depending on the pricing, we go for a flat pricing structure as well to try and make it as easy and pain-free for the customers to turn up these services, which are billed on a daily basis. So they can turn up a circuit in 5 to 30 minutes, and they can turn it down the next day and only pay for a day's use. So although it's actually per megabit per second more expensive than what could be available on a 12-month or 3-year contract, it's still very cost effective for someone who has a need for agile services, or at least turn up a service quickly and then turn it down when they've got the real thing from the provider locally in 3 months' time. In addition to Equinix Fabric, we've got these other things called Network Edge and Equinix Metal. Network Edge is just a very simple kind of Equinix bare metal service where we run hypervisors and we'll spin up various kinds of op systems and disk images for customers that want to run things like virtual routers. So we can turn up Cisco CSRs. It's very much enterprise class. It's not aimed at carriers or service providers. But some managed service providers are using Network Edge to turn up things like firewalls, Fortinet firewalls, Juniper firewalls, VPN head-ends, as well as I say, the very simple kind of low-featured routers as well. Equinix Metal is the jewel in the crown, and without giving you a lot about Equinix Metal, it comes out of Equinix's acquisition of Packet, the company Packet, and they have now deployed in 28 metros worldwide, with another 5 in the pipeline. And it really is the jewel in the crown. It's a very complex bare metal offering. It's not just a simple server. It has ASICs installed. You can run OANM to your devices as well, so you can run virtualized CPE. You can actually run core routers, not necessarily full global routing table, but certainly very highly featured. And it's a bit of a workhorse, so it's also peered. When Equinix Metal, which won't be here day one, but when it comes, which it will be peering a couple of 100 gigs on Jinx for sure. And then we'll also be taking transits for it, and it also has availability of PNI. So you can kind of run it as a telco or an operator, service provider, or an OTT player. You can run it as own infrastructure, either permanently on an OPEX basis, or it can be run on an OPEX basis until the real kit arrives that you've bought. But in a time of silicon shortage and getting through customs control and stuff can be a challenge. So it overcomes the service time to service delays that can incur. Equinix Fabric, I prefer to think of it this way. There is actually a link in this, I believe, at the top. The building blocks of digital infrastructure on the top here. If you want to look more at what's entailed in these digital building blocks, you're very welcome to just check it out from this slide. Basically, what's attached to Fabric is Fabric connection to multi-cloud. There's also connection to multiple service providers. So again, network as a service, it is a service off of Fabric. This is very much for things like Ethernet services, MPLS services, not so much transit, because there is the typical way of doing that, which doesn't need to be fixed or changed. Some, such as Verizon SDI, Colt ODI, have agile networks that are software defined, and they can actually API into this platform, so it's possible for customers to turn up their own network services off of Fabric, either for last mile delivery or WAN services or metro services. It does mean that Equinix Fabric building blocks, for anyone in the room who is an internet service provider that has a point of presence in a third-party co-location facility, whether Terraco, ADC, or any other, can actually deliver these services to their customers. Now, I obviously understand most people will have access to public clouds already as part of their portfolio and selling it to their enterprise customers. This is a very agile way of delivering that service, but in addition, although the marketing speak here says 500, it's around 400 and something SaaS and cloud providers worldwide that are attached to Fabric in multiple locations. So it's possible to reach just about anything somewhere in the world. And then we've got the network edge devices, which is the virtual devices I already talked about, and a number of service providers that are running private cloud offerings. Also NVIDIA Launchpad AI as a service is available on Equinix Metal, Kubernetes, Red Hat, Linux, and Amazon Elastic Cloud Services and Google Anthos. You can flex workloads between the private cloud instances running on Equinix Metal and the public clouds. We are in addition recently hosting virtual routers to support user plane function for multi-access edge compute, which Michael was talking about earlier in the context of 5G. The CUPS piece, that is control and user plane separation, does mean that every application can have the user plane function in a different place, and in fact it's imperative that it does so for performance, cost and latency reasons. So we're playing our part in that whole future-looking stuff, which may not be big in South Africa now, but I guarantee it will be coming at some point. Then we have a number of SASE providers, and finally we offer Equinix Precision Time, which is a 50 nanosecond accuracy clock, which is available through Fabric. I'm going to go very quickly through these at a ridiculously fast rate because I'm sure I'm running out of time. But these are various service providers that are using Equinix Fabric today in all sorts of ways that really it's a delight, because they're coming to us with the use cases and then we turn them into case studies for them. So Orange Telco Cloud, which is their SD-WAN service, is running on Equinix Metal in various parts of the world that previously were off-net to Orange. Some of this is again due to procurement lead times and due to problems with customs control and getting stuff into the country installed and turned up. And on Metal they were able to turn up their service, which is now fully functioning as far as I'm aware, in multiple locations that would have been a struggle for them otherwise. So that's the first partner which is using Equinix Metal. Oh, sorry, I've gone one too far. British Telecom has a service called Connected Cloud Edge, which they launched last year. That runs on Network Edge. So basically, they white label this. One of the things I have to say is that there is no particular sales motion, productization, that is excluded by Equinix in any way. So we will support any kind of sales motion, resale, white label that a telco or partner wants to adopt with us, and we'll support them fully. So Network Edge bears the BT brand as BT Connected Cloud Edge, and they are offering a fully managed cloud service to enterprise customers, which is both multi-cloud and also extremely agile. Colt ODI, as I said, last mile service. This is a global solution involving Colt delivering last mile services in Japan. In Hong Kong, it's actually Hutchison. In the UK, it's Colt again. And we have a managed service provider managing the infrastructure using Fabric backbone actually as the SD-WAN, and with 2 diverse connections into Azure in Asia Pacific. EU Networks are doing a high-powered computing thing for researchers in life sciences at Cambridge University. The upper limit of functionality on Equinix Metal exceeds anything that's available on public clouds, so it's ideal for things like high-performance computing, particularly where there is a need either for low latency or for confidentiality and security. Telstra is fully API'd in, and they provide TPN, which is an all-encompassing resale of Equinix services from their own portal, and it's basically white-labelled. So, Nokia at Mobile World Congress were giving an example of enhanced mobile broadband, EMBB, which again was talked about earlier, delivering 8K streamed content from a football match, I think it was, with Elisa, the mobile operator, with very low latency and extremely high end user quality of experience. Finally, on Network Edge worldwide, Equinix has introduced the Edge Developer Platform so that various developers can actually emulate mobile networks and can test applications across a very wide area if necessary, so they can emulate roaming and performance under those circumstances, which would otherwise be very costly and time consuming, and it can be turned up very quickly on Equinix Network Edge. Enhanced mobile broadband, don't really need to say anything about this. With 5G comes lots of streamed cat videos, and although network slicing and enterprise stuff on 5G is much talked about, it's still very much a nascent market, whereas people are streaming like crazy video at ever-increasing quality, and so the need for mobile operators to uniformly come into line, maybe on what ISPs have been doing for some time with peering locally on IX and with each other, may come into play. We certainly hope so. Even in Europe now, with some mobile operators such as TIM in Italy and T-Mobile in the Netherlands, we've seen the old practice of hairpinning traffic in and out of the upstream provider to a remote location for peering, and that is disastrous for 5G, really. This is about Equinix and sustainability. I'm not an expert on this at all. I'll probably use all the wrong words, but I think the important thing is that Equinix is fully subscribed to this, and I know we've got a panel about this in a minute. What I'd like to say is that I believe the company, and this is not marketing at all, it's just responsibility, has moved to a power procurement policy of 100% renewable energy for all of our data centers, and we're at 95% so far. And so we need by 2030 to be at 100%. We're doing various things to get there, changing the temperature at which we operate our data centers to fit with the American ASHRAE standard of 27 degrees centigrade as the upper limit. So we're running everything at the upper limit, which makes it quite uncomfortably warm for humans, but at the same time it reduces the cooling requirement by about 10%. We're also moving across to different forms of cooling, including passive cooling, adiabatic cooling, using water. Where water is constrained or in short supply, we're using novel forms of air cooling. We're also, in terms of energy, looking at solid oxide fuel cells away from conventional. Obviously, when we launch here initially, it's going to be diesel to cover us with, typical backup. But over time, all of our data centers will be moving to whatever's most efficient that we can procure. The benefits for our customers, of course, is that they can use us to pass off their Scope 3 stuff. So if we become their supply chain and we've got good green energy records, then they can pass off their Scope 1 and 2 by outsourcing to us. And that's something that may not be a big thing here now, today, in South Africa, but in Europe it's becoming mandatory to have a green energy certificate, and access to affordable finance even depends upon being able to flourish one of these certificates. The thing that I'm most proud about at Equinix, and then I'm going to get stopped in 2 minutes, is Equinix is the most remarkable company that I've ever worked for in terms of multicultural, gender diverse, you name it. We all just kind of mix in together. I've never worked with so many smart people. I'm sure maybe you guys have done so for a long time, but certainly in my long career, I've never worked with such a wonderful mix of people from all kinds of backgrounds, all pulling in the same direction. So it's been joyful. And this key mantra here of, every day, every employee should be able to say, I'm safe, I belong, I matter, isn't just mere words, I have to say. That's it, really. The only thing I would say is that the ESG, the last bit, was all to do with global responsibility and partnerships. And you've seen what we do as a company now in this crazy whistle-stop tour. It isn't just about customers, it is about partnerships. We need service providers, and we hope that you will come to like us and use us as well to grow your business, but also to, more than anything, do things that are really important, like close the digital divide, stimulate the digital economy, and bring about the next big change for the benefit of everyone and not just for a few. That's it. Thank you. Any questions?
Any questions or comments? Come up to the mic and your name. Thank you.
Oh, hello.
Thanks. Mark ZANOG23, Africa. You said you bought the main one in Lagos.
Yes.
So you mentioned that there's no connectivity, but there's the main one cable into the main one.
No, we acquired the entire company, so there is a cable system, there is a terrestrial network, and there are a series of data centers. So Equinix is particularly focused on the data centers, and what will happen over the coming years, and not too long a time, is that there will be a divestiture of the cable system, and either total divestiture or a separate holding company set up for the terrestrial network. Over time, it's not Equinix's core business, and it just doesn't sit at all with our business model. So that's what's going to happen over time. I'm not the right pay grade to tell you over what time, but the terrestrial network will increasingly become more and more important, I think. The subsea cable system, there's plenty of people that will be liking to buy it and acquire it from us, so I suspect that will happen at some point.
Okay, so just another question. Your differentiator coming into Johannesburg as an open access DC, is there anything you can talk to about that you feel is going to make you stand out in the market?
Well, as we said there, is like the standard model is the interconnection model. It includes internet services and all that brings with it. But, sorry, go on.
I understand, so I saw obviously all of your add-ons, but I'm talking, let's talk power, let's talk key in South Africa, or you've got a major issue.
Yeah. Okay, well, I did ask about this. I did ask because I thought the question would come up. So firstly, our backup will be batteries followed by redundant diesel. In terms of the actual power supply itself, I'm told that it is exempted from load shedding. It's a high voltage supply. I know very little about it. You know, data center design is not my thing, but I asked this many months ago of the team that was procuring the various services and the location, etc. So I understand it shouldn't be as prone to load shedding and should be more stable.
Are you allowed to share the exact location?
Well, I would if I knew it exactly. No, I'm hoping we can find it tomorrow. Ed's going to take me, and I'm being genuine, seriously. But I'm hoping Ed will take me tomorrow and we'll try and find it. And then hopefully next time I'm in town, I'll be able to say more about it. Thank you. Thank you for asking.
Great, thank you.
Thank you.
All right, folks, give us a second here while we set up.
Sorry. What, you want this? Oh, this is a souvenir. Okay. Thank you.
I'm going to have put another one on. No, I have to put another one in the pocket here. That's for.
Oh, is it somebody else's? Oh, okay. Well, I didn't realize. Is this the recording? Ish. No, go for it. Yeah. Take it. Sorry, this is 7. So no. We can try and do this so that we can plug that in and keep it on the side. Oh, okay. Yeah, no, that's all. Okay, one more. There's one more. Just want to see if everybody turns up.
All right, folks, if you're on the panel, please come on up.
I'm just going to swap. See if I can actually swap this. Where's my techie guy? Swap this. Can I swap the laptop?
Audio coming out of there?
No, it's no audio. It's just that. That's all I need. Okay. That's great. No, we're fine. Whoops, that's not what I want.
I don't know.
Yes, please join. I'm not going to ask you many. I'm not going to ask you too many complicated questions, but please join.
Please don't.
I just want to get the screen mirroring right. Okay. Alright, grab a seat. That's how things best. There we go. Just to pop that up. And we go.
All right, great.
Right.
Folks. My pleasure to introduce Angus Hay. He's going to be the moderator of this panel. And he's got a very long list of folks up here, so I'm going to let him introduce who his panelists are. And with that, take it away.
Thank you. My mic is live. I just realized that this podium might be blocking some people. So I don't know how far back we can move it, but we'll try and keep it. Just shout, move if you want to see the panelists. It's going to be a little bit challenging. Okay, so maybe just to start with a quick introduction. I'm not going to talk much about slides. I just want to put a couple of things up. These are the triggers for what we want to talk about today. So the title of the discussion today was initially presented as data centers in the time of load shedding, and I thought, given the audience, that would be a bit unfair to sort of limit ourselves to talking about data centers only, and so I've added the and networking because I'm guessing that half the audience has an interest in and networking. Also, we're not going to confine ourselves entirely to load shedding because I think there's a much broader field of power, sustainability, renewable energy, green, etc. So there are a lot of things we can talk about, and we have quite a diverse panel who are going to touch on a number of those subjects. So the first trigger was just one of those favorite South African graphs. For those who don't know what this is the graph of the number of hours of load shedding in the last year. This is taken from real data. This is not from the published tables. This is actually recorded in particular areas. So that's roughly the amount of hours that have actually happened over the last year. And as you probably know, there's a difference between South Africa and the rest of South Africa and the city of Cape Town, because they have a slightly different approach to managing power. I'm not going to talk about that. What I'm going to do is introduce the panel and let them talk about it. So I'm just going to go through, I don't have long CVs for everybody, so thank goodness. Instead, what I'm going to do is just go across the panel, and in no particular order. I think the order we have them here, I would like to just do quick introductions. So if the microphone is live, I'm just going to give a quick introduction, and then if each person can just kind of give a little bit of their background and what they actually do in the industry. So starting at the beginning, who's first here? So Juanita Clark is Chief Executive of an organization called Digital Council Africa, and I'll let her explain.
Thanks. Hi, colleagues. Afternoon. Thanks for staying around. So I founded an industry association about 13 years ago. Our core focus at the time was on building out fiber optic networks and educating governments just on why fiber was necessary. It was the early days when the DFA was this disruptor. You'll remember the Altec ruling going to court and suddenly today we've got 400 ECNS licensees and 50 FNOs. We've changed our focus slightly over the last 3 years since the onset of the pandemic, and we've taken on board tower codes as well as data centers. Core focus still just being the build out of digital infrastructure, mainly fiber, towers, and data centers. I would take some mic back. Sorry.
Thanks, Sunita. Okay. Yeah. So just while I'm doing this, Agus Zolna is well known in the industry, but his current role is as business development for Digital Parks Africa. And if you don't know what that is, they run data centers.
Thanks, Angus. Yeah. So, despite my accent, I've already been 40 years in South Africa and spent my life in the telecommunications infrastructure game, starting with fixed exchanges over mobile networks, mobile devices, and the last 7-8 years in the data center business. Digital Parks Africa is an operator of a number of carrier-neutral data centers across Gauteng and one in the making in the Western Cape. Thank you.
Great. Mark O'Donoghue is Chief Sales and Marketing Officer at Link Africa, who run networks.
Yes. Hi, everyone. Mark O'Donoghue. I spent 11 years at Internet Solutions, so heavily involved in the building of networks in South Africa. I then spent a year at Liquid Telecoms heading up the enterprise business, and then moved to Avanti, which is a Ka-band satellite operator over Africa and Europe. I did a lot of work throughout Africa, and then I've returned to South Africa with a company called Link Africa, and went full circle in the sense that Link Africa bought the Internet Solutions fiber network.
Novuyisa Bachi is Chief Executive Officer of another organization, the Association of Communications and Technology, and I'll let you introduce it.
Thank you, Angus. Good afternoon, everyone. As already introduced, my name is Novuyisa Bachi. In the main, where I come from, I've been a regulator, both from the Competition Commission, ICASA, and I did a stint at ZANOG23. Then I moved to be the ministerial advisor, and then I became the head of the PC4IR within government. Other things that I've done have nothing to do with this sector. In the main, the Association of Comms and Technology, it's a new industry association that was formed in 2021 by the 6 telco operators that are involved in the infrastructure: Cell C, Telkom, Vodacom, MTN, Rain, and Liquid Intelligent. What we do is to ensure that the main purpose when we were created, I would started last year in April, was to make sure that government gets to understand the ICT ecosystem as it stands. As you would know, that we haven't had any policy change since 2005 and 6, and we wanted them to understand where we're coming from. However, this has sort of been changed a bit. The focus has been more now on the issues around load shedding, issues around ESG and the likes. So I am looking forward to being in this panel. Thank you.
Great, thank you. I think the next person needs probably no introduction, but I'll let him introduce himself. Mark Tinker, who's head of engineering from CCOM.
Thanks, Angus. So Mark Tinker, I head up engineering at CCOM. I'm standing in for facilities guys, so hopefully I do a half-decent job. I monitor ESCOM on Twitter every day, so hopefully I can be of some use.
Okay. And also, I guess, the next person, Martin Atkinson, has just introduced himself, but I'll let him introduce himself again.
Yeah, hello again, Martin Atkinson, Equinix. I've been with Equinix for 12 years, and in that time I've seen the company grow from just entering Europe for the first time to being fairly well globally distributed, entering Africa really for the first time last year, which was kind of a long overdue move, I feel, really. My role in the company is kind of business development, really, with a focus on technologies and customers, partners that promote interconnection and new services.
Good. Okay, I'm going to try and focus the questions towards people who can answer them. So the topic, as I said, is not entirely on load shedding. We're not going to talk about a few other topics, but I'm going to start on the topic of load shedding, which I think is probably quite on everybody's minds. I'm told that we might actually get load shed in the middle of this, which would be quite ironic. So let me start with Eckert from a data center perspective, and just how has load shedding actually affected your business? And in what ways is it continuing to affect your business?
Yeah, so it's made us extremely friendly with our diesel providers. Just to give you an example, the cost of producing a kilowatt hour through diesel generators just roughly 3.5 times the cost that we can purchase it from the local provider. So it's obviously got an enormous impact on our bottom line, and as a data center provider, you can't pass the full cost onto your customers. Customers traditionally have a certain amount of diesel hours included in their monthly fee, and once you exceed that, it becomes a negotiation often to try and recover some of that cost. So it's made us acutely aware of the risks that we face in South Africa, because as a data center provider, we sell an SLA, we sell uptime, we sell availability, and all of a sudden, if due to our political environment, our sole provider in the country is at risk of falling over, it's a tremendous threat to our business. So we set ourselves very steep targets in terms of gaining our own energy independence, or before that even bringing on our own second source, gaining our independence, and in parallel looking at greater efficiencies. And I think Michael mentioned a lot of those efficiencies, first and foremost, for instance, things like cooling. A lot of very exciting technologies coming to the fore in cooling, liquid immersion cooling, for instance, promising around about 25 to 30% improvement on an overall PUE. So yeah, it's brought all those things to the fore and accelerated the adoption and the evaluation of such technologies.
Okay, good. Maybe just pass the microphone on to the left, Mark, from a network perspective. Maybe just take the same question, but perhaps sort of to tack onto that. As a network provider, beyond the impact it's had on your business, what are you doing to deal with it, which is somewhat different to the data center environment?
Yeah, so it's certainly been an interesting time, especially with the amount of capital that the company has had to outlay in order to ensure that our nodes and core network remains up. So what we've had to do is completely redesign our backup systems, the way we actually use gensets. We've had to upgrade over 400 nodes at incredible cost, all into lithium-ion batteries with gensets that will keep the nodes alive for more than 24 hours without any human contact. Everything then being integrated into a monitoring system that we have to run through our NOC, which is constantly monitored to ensure that our SLAs are met and ensure that our customers are happy. As Eckhart mentioned, with the network space, clients are still pushing the price or demanding cheaper pricing in the market, and we have to play quite a difficult game in the sense that we have to try and keep the clients happy as well as keep them up, and then still unfortunately absorb all of this capital cost that we've had to put into the networks to keep them alive. From our side, I think we've done actually extremely well with it. Our uptime on our core has been more than 99.9995, and our core in Cape Town has been at 100% uptime. So some very good statistics coming out of our company at this stage, but at tremendous cost to us as an organisation.
Okay. Maybe Mark Tinker, just on a similar note, you guys have a much broader footprint that extends way beyond South Africa, but just for the South African parts of your operation, do you have similar issues? Have you put in place similar measures?
Yeah, I think everybody's pretty much doing the same thing, so I probably won't label that too much. I think what we're looking at now is a potential, multi-week, Eskom blackout. That's sort of what we're planning for at the moment. And when we do the numbers, it just doesn't seem like we can keep the entire network up. The cable landing stations is reasonably simple because we just need to truck diesel in. The transnational line system is a little bit tricky because you have different huts along the route. You're talking 600, 700, 800 kilometers. And you know how you can reliably keep power going at those places, considering that we do get quite a lot of robberies in those huts as well. So you could put up a solar plant and it will disappear in a week. So that's also challenging. I don't think we can do much about the metros in the cities because commercial buildings are unlike data centers. So you get what you get, right? If they can only supply you with 8 hours of diesel or 1 hour of EPS, there's not much that you can do about that. Across the rest of the cable system, we run into these challenges in Kenya, in Tanzania, and Mozambique, so we have plans for that. But it's for us now, we're just looking at what happens if Eskom is out for 2 to 4 weeks. And there's not a lot of the network that we can keep up. The landing stations, yes. Terracos, yes. The long-haul networks, maybe, maybe not. And that's the real issue now.
So, maybe as an international player, you also have a view. Sometimes from a South African perspective, and I guess this is also a South African habit, we tend to portray load shedding as being one step short of doomsday. And that perception does carry internationally. Just objectively, when you compare the various operations in different countries, how bad is South Africa versus other countries, or is some of this just our perception? Sorry, to Mark as well, yeah.
For me?
Yeah, absolutely.
You mean in Africa? Or
yeah, specifically in Africa. I guess when we're talking about developed countries, people always say,
yeah,
it's fine. But I think on the African continent, we have created for ourselves a reputation which may or may not be deserved.
Yeah, to be honest, I grew up in Uganda, so South Africa is a bit babied in this way, to be honest. We grew up without power for many hours, and we had no schedule to tell us it was coming or going. So places like Zambia, for example, have improved, but you do get outages of easily 18 hours a day. Zim, you get outages of about 20 hours a day. It's markedly improved in places like Kenya and Uganda, but that's not because of increased generation capacity or better distribution. It's because of low electrification, right? So if you're only electrifying 29% of the country, then half the generation capacity that you produce is not going to go anywhere, right? So it's not a useful metric. If you had to put all those people online, then you'd be in the negative real quick. So South Africa doesn't have it as bad as many countries that I've been to. It's just that South Africa is a lot more industrialized, so the impact is much more significant. And because the electrification rate in South Africa is, in the 90s, think of Mauritius or Egypt or something like that, the impact is really felt. But there are worse places to be in Africa than South Africa.
Okay, I'm going to stay on this topic, so I'm going to hop around just between the network and data center people. I'll come to the rest of the team. Maybe back to Eckhart, you started to mention other things you're doing. So given that we used to be a country with stable power, and we're not at the moment, have you changed your design principles, your approach to how you ensure you have sustainable energy?
Yeah, we've sort of always made sure from a design approach that we design for a number of layers of redundancy. It's just a different topic when all of a sudden you're having to use it much sooner than later, or when you're having to use it much more than you initially anticipated. So in practical terms, in the data center world, what I mean by that is we've designed our data centers towards a tier 4 architecture. In other words, we are able to become our own primary electricity generator at medium voltage level. And we've learned by deploying that approach, rather generating at 11 kVA than at low voltage levels, that we were able to leverage a whole lot of efficiencies into the system, reduce the switching incidence of the downstream switching gear, and the whole infrastructure that wasn't originally designed for being switched on and switched off all the time. What was originally designed as emergency systems have now become routine operational systems. So yeah, we absolutely have learned from that and adapted to that.
Okay. I'm going to come back to sustainable energy and some other discussions, but I just want to move across into the sort of broader industry perspective. So we have a couple of representatives here who are from industry bodies, but who've certainly over the last couple of months have been very focused on the bigger perspective around policy, regulation, industry, what do we do? So Novoyuso, just talking from perspective of a group of operators, I mean, is there anything that utilities or government or the industry as a whole should be doing to address the broader problem of load shedding? And maybe those are different answers for each one.
Thanks, Andrew. So, in simple terms, especially when it comes to load shedding, as you know, last year, September, I think that's when we all experienced the worst load shedding. Then there's a date in December, between the 19th and the 20th of December, we had no network operator was able to call another network operator, just a basic voice call. It's just that most people were on leave and they didn't pick that up, right? And you could only make WhatsApp calls. That's the day I think we had the major panic, and then we started engagements with, seriously with government, because we have had them before, but it was more unstructured. I'll use that word. It was more unstructured. We were going there on an individual basis. Then on the 23rd of December, we realized, look, this is a crisis. We need a plan. How can we go about having a plan for our country? And then we came around with issues such as you have entities such as I know people don't have faith in them, Transnet, the Prasas of this world. How can we use partnerships with those companies insofar as dealing with the issue of that you mentioned earlier of vandalism? Because if there is load shedding, the next thing that happens is vandalism, theft. So we started looking at those small problems. Then we said, from a NERSA point of view, we've heard that you guys are having this massive increase, but we do not know what plans do you have for end users. We want to have you guys to have a plan for end users and to tell us what does that plan entail. Being honest with yourselves is that we went to a NERSA that said, look, we are noticing a number of people coming to us, but we are a NERSA that only dealt with ESCOM and municipalities. So you have to come up with solutions, and we'll come with those solutions together. And then we said, okay, we want a tariff framework for wheeling arrangements as to how would those happen. Doesn't matter that doesn't make a difference that one network operator will be chosen over others in terms of doing a pilot. What will be the sustainability moving forward? Then we also said to government the issue of fuel rebates, right? This is quite an important issue. That especially people that are burning diesel, if you think of the data centers, yes, they come in built with diesel capacity, but no one has ever anticipated the amount of money that will be spent, and you cannot pass it on to end users. We were told, frankly, no, not this round. You have to look in another direction. Because there are certain things that we expect from the economy, but we will hear you if you can bring us a proposal as to how that can be done. So in a nutshell, what I'm saying to the colleagues here is that we have a responsibility to work collectively with government. So as Juanita is here, we've had the opportunity to actually engage even with the new Minister of Electricity as a sector bodies to say, what are the things that we can do for you and what are the things that we would like you to do for us? If you think of the Competition Commission, people that want to generate their own power, but you can't do it because you're so small, but you want to partner with other people. How do you deal about those things quicker without being a burden? How do you facilitate those arrangements? So we were saying as on behalf of the associations that in a nutshell, government has to come up with an integrated approach, right? The similar way that they've done it during COVID. They need to keep updating us as to how we can help and how they will help us. So it's more multi-pronged approach, and I'm going to, because I know some of the things we're doing jointly with Juanita and her team. So it's for us, how we're looking at it, it's not short term, it's even after the state of national disaster is over. How do people invest long term, and they have guarantees on those investments within our context of South Africa? I hope I've partly responded to your question.
That's great. I think a good segue for Juanita. A number of the players in the room are quite likely members of Digital Council Africa. We certainly have a number of the players in the business. Maybe just to kind of bring it back to specifics. So have you taken any specific action as DCA? What is the approach that you're taking as DCA, and how are you addressing some of the issues which Nomiso has raised?
Sure. So I just want to say something at the risk of getting thrown with a full water bottle. The data center sector is almost like a victim of its own success, and the telco sector to some extent. Companies just got on with it. They just started building fiber networks. They navigated the municipalities. We just earlier this year had the standard bylaws passed for applications, for wave infrastructure. It was 12 years of really hardcore lobbying to pull that over the line. When we did, it took us 6 months from inception of negotiation to, when it was pulled over the line. The biggest problem that we're facing right now, and you'll know this because you were in a meeting last week, is that there's a lack of understanding of data center infrastructure at government level. Technically, people don't understand what a data center is. We literally had 24 people last week visit Africa data centers and doing a data center 101, like this is why it's important, this is why it needs to be given special attention, and taking them through the process so that they understand where data centers fits into the architecture of telcos. And it's difficult that, we have to start there, but the fact is that, we just got on with it, we built it, and it's worked till now. Yesterday I was in a meeting. I actually sent Buyo a WhatsApp because they had to pick me up off the floor, because yesterday we were in a meeting and I mentioned the statistics. There's 49 data centers in sub-Saharan Africa. There's almost 5,000 in the rest of the world. Therein lies the opportunity, which is why, you know, we're seeing more and more data centers come. And somebody stood up in a government capacity and said, well, we don't know if we want them here if they suck so much energy. And I was like, sorry? Like what? You know? So it's tough, it's hardcore, you've got to get out there, we've got to like start from ground zero, building up knowledge, capacity, etc. Because it's never been done, you know, people don't understand data centers. We've been fortunate in the last 3 months, we've had meetings, extensive meetings with the Minister of Electricity. He's really got a great vision. He's got to move the needle, you know, on things. So he did a good presentation to us. He's joining our board meeting again on the 30th of March to talk to our, you know, our board members about what their plans are, the progress that they've made. So there seems to be some commitment. Tomorrow there's presentations to the regulator in terms of potential solutions, but everybody's sort of asking for exactly the same stuff, wheeling agreements, you know, it's the same nuance through all the industry associations, just asking for, you know, it's easier with data centers because obviously, you know, it's not like towers where, you know, you've got this decentralized sort of architectures, data centers. You can at least at some level, you know, sort of give them relief, either if it's, you know, after stage 3 or one of these levels. But there's really a lot of stuff that's happening. You can, whatever is humanly possible between ourselves and ACT, the SACF, we're honestly trying the best that we can.
Okay. Right, so Martin, I didn't want to throw you in at the deep end because you kind of new into this, and but maybe just, I'm going to flip forward and slightly shift the topic, but we can stay with what it is we can do about things. So just talking, you'd spoken quite extensively in your presentation about sustainability generally. So, you know, given that there are challenges with both let's call it the availability of power, and you know, and this is a general problem across the African continent, as Mark had alluded to. You guys are operational in Nigeria, you will know that well. But it's not just that. There's a separate problem, and particularly in South Africa. For those who don't know, our current national grid is about 85% non-renewable. So we have a huge opportunity at the same time as addressing the fact that the power is off when we don't want it to be off, of dealing with a transition, what's been termed a just energy transition to sustainable energy sources within South Africa. And, you know, Juanita kind of alluded to it as well. There's a lot that industry itself can do directly. So from an Equinix perspective, firstly, in a broad sense, how do you deal with the challenges around availability of power? You're going to see them in South Africa. And then, you know, that whole transition to a more sustainable power.
Yeah, well, actually, I think what's quite interesting is, and I think there's availability issues and then there's cost issues. And excessive cost is just as much of a problem as lack of availability. Because if you can't afford it, you know. And so at the moment in Europe, we're suffering very much with, you know, grossly elevated costs, which has created a huge problem for everyone in terms of operating margins disappearing, etc. And Equinix having to pass that on to customers in a way that is equitable, you know, that ultimately prices come down, we've got to confer that back to the customers. So we've been using hedging for that, where we contract for 12 months and sort of hedge that it's not going to drop too soon, and if it goes up, at least our customers are protected. On that broader question, there has to be a political will and a political drive and incentive for many peoples, because otherwise they will act in their own interests. We're all human and we all tend to do that. So I think I've been really surprised at the speed with which things like various, you know, green certificates, etc., are required, and in fact mandatory reporting is effectively now, you know, a legal requirement in much of Europe. That drives people's behaviours, because otherwise there are severe penalties, and that's really getting behind the Paris Agreement of 1.5%. at 1.5 degrees. So I think people's behaviours are being driven, and as I may have said, I can't remember if I did, because it was such a kind of a trolley dash that last presentation, that availability of finance is being linked to these certificates and reports as well. So if people can't come up with a favourable renewable energy report, sustainability report, then they suffer financially. While you're in a situation where the whole country is, you know, basically got no option but to consume brown energy, then it's a bit difficult to influence people's behaviours, which is why, to some extent, the end of my speech there was, if it comes, you know, you'll share our pain, you know, in terms of this is what we've had to address, and it brings obviously huge global benefits. And it's extraordinary the resourcefulness that it creates, because you immediately start looking at not just the cost of or the availability of power, your efficient use of it, which is not only just how you consume it, but also how you cool. Can you use alternative technologies? With the wastewater and the excess heat you generate, can you perhaps supply that to someone else? And certainly in Bordeaux, Amsterdam and Helsinki, the wastewater from our cooling systems is actually shared with the local community as domestic heating. So it's not wasted energy, you know, it's at least, and that's some kind of offset. So I don't think there's one simple answer to this, but I think that the political will and initiative has to come first to force people to come into line. Otherwise, people just act in their best interests always.
A follow-up. You mentioned in your presentation that, you know, globally Equinix has a significant percentage of renewable energy in the mix.
It's 100% in the US.
Yeah.
And it's
So the obvious question is that going to translate into particular initiatives when you're deploying in Africa? Do you have plans to address that in Africa?
Yeah, well, I think we'll work with what's available, because that's always the case. You know, as I say, where we can shed excess energy and use it for heating the community, great. Where we can use alternative sources of power that are maybe not even generated, but, you know, are wind energy or solar or something, we'll do so. Or use it to reduce our power consumption. So there's no one, and the data center designs tend to be very much influenced by what's available, with the objective of getting to the lowest possible PUE we can achieve.
Yeah. Hopefully everybody knows what PUE is.
Oh, power use efficiency, yeah. So.
That's how we measure how efficient the data centers are. Great. So just, you picked up on something interesting, and I'm going to ask Mark Tinker this question, do you think that the consequence of the kind of shift we've had in energy in South Africa is affecting the competitiveness of our networks, our country, our data centers across the continent and elsewhere? I mean, are we slipping backwards? You know, would people rather be somewhere else where the power's on? Is it more expensive now to operate in South Africa than it should be?
Yeah, I think the perception is that it's both more expensive and somewhat unpredictable to operate. But you know, like I think Yolandi was showing earlier in the morning, is that there's a significant amount of eyeball interests in South Africa and surroundings. And so I think, you know, while it is uncomfortable, it does not, you know, chase interest away from South Africa. You know, we know that, you know, data center operators will still, you know, invest massively in electricity, either from, you know, fuel or other sources, wood if they have to. So I think that won't keep people away. But yeah, I think there's, you know, as Martin was saying, there's a resourcefulness that's going to emerge. And I think, you know, as dire as the situation looks right now, it's actually a great opportunity for us to try something different, you know. And I hear what you're saying on, you know, government doing, you know, 8 or 9 or 10 different things to get to a solution, but I think also giving people the opportunity to, you know, generate their own power, specifically in South Africa where there's a lot of sunlight, is I think a big part of that solution. I think the model of a grid scale network that everybody can tap into, I think in our case doesn't really work anymore. I don't think ESCOM is going to be able to get to where it was 2 20, 30 years ago. And I think trying to make that happen again, I think is a fool's errand. So I think that people should be empowered more to focus on generating their own power, at least here in South Africa, because then that drives user behavior in terms of how they demand energy. You know, the days of just walking in and flipping a switch for your kettle is not going to happen, which is fine, because then people will self-regulate, and then maybe it takes pressure off Eskom to service the large, hungry data centers that need the energy, and then the rest of us can just, see what to do. So I think there's an opportunity there, and I think the government's insistence on being a huge part of that shift is holding back what could be extracted from just giving people the opportunity, either through funding or through regulation or through tax relief. I mean, this 15,000 Rand, 25% tax rebate on, so I mean, it really doesn't do anything, to be honest. It's, it's like we're doing something, but we're not. But we're doing something, but we're not. Right? If we really wanted to go far, we'd say, look, we'll give you a tax rebate of at least 100K, including installation, inverters, batteries, etc. But solar panels, really? You need to buy like 1,000 of them to make it worth your while. And even then, you're only getting 15,000 Rand back. So it doesn't make any sense. So I'm saying, if the government can do what they need to do, but get out of the people's way to some degree, I think this thing moves forward faster, because if we all have some degree of independence on generating power, we can better control the actual overall, use of it. And for me, I always say, I'm not much of a green guy. I just like power. So if it so happens that I become more energy efficient as a byproduct, that's fine. But I'm not doing it, to be green. I'm just doing it to have power that's more accessible.
Okay. Mark O'Donoghue, from a network perspective, just maybe a little preface this, I put a slide up. From a data center perspective, it's kind of obvious we have big power requirements. We would like to generate as much as we can ourselves, because we can probably do it cheaper than utility. We put stuff on site. And I think what has been alluded to by a number of panelists so far is the whole idea of being able to buy from an independent power producer. Whether that's renewable or not, but just the principle of being able to buy from an independent power producer that you've got control over the source and you're paying for it directly. Based on what Mark was saying, I mean, as a network, what would you actually like? I mean, if you had a choice of policy and what you'd be allowed to do as a network. I mean, there was a comment about, you can put up solar panels, but maybe they'll get stolen. Yeah. But in terms of framework, what would you be like to be allowed to do that would solve a lot of your problems? It's a tough question.
It's a tough question, but we as a network provider rely massively on the data center. I mean, we terminate all our cores into an outsourced data center. We don't run data centers per se. We run our networks in data centers. So obviously our preference would be that these data centers are highly focused on green energy, and that we also don't suffer the costs of the pass-through diesel costs. But right back to that comment around the security, you can't separate these two in South Africa when it comes to power and security, and I'll explain my comment. We're currently spending over 500,000 Rand to R1 million a month in KZN alone on security for our staff in the field. We have a very large network running in throughout KZN and into the rural areas. It's quite unbelievable, the stories that I could tell you. So us putting any form of solar panels or anything that is visible is literally ensuring that those units will be stolen. We have to be very conservative in the way we mark our nodes, how we put lithium batteries in there with generators. It becomes an absolute target. Simply look at Vodacom and MTN. You can't, they now rotate their batteries. They can't keep their batteries in towers for longer than a few days because they become a target, because people know that those towers are now up during load shedding. So now you move the batteries around. I mean, it's a completely ludicrous situation. It comes down to the security. We're actually, I'm setting up a meeting in Durban next week, trying to get all of the carriers in a room to discuss security, because it's actual physical, life-threatening security risk to our staff. So back to the power, if we were to try and do this all on our own, we would literally be just reinvesting and reinvesting in solar panels, etc. So yeah, difficult question, but overall this subject in South Africa cannot separate security, because when it's dark and our guys are going out into the field to try and repair network and there's no light, all of our equipment gets stolen, our vehicles get stolen, their lives are put in danger. We have to have now fully armed guards with them. It's quite an unbelievable situation and a little depressing. I don't want to depress the Karun, but the bottom line is this whole ecosystem from a government perspective needs to all come together. Security, power. Without the power, your country citizens cannot have work. The circle of theft and what's the word, looking after yourself, becomes a vicious one. And we all just need to ensure that these forums, etc., are taking on government on all aspects that affect our ability to do business in this country. It's so bad that you've got to just look at the economics of us in being out in rural areas. So on one hand, you're trying to be, you're trying to empower, you're trying to provide the connectivity, the backhaul, etc. for wireless networks, for cellular networks. But then the viability of it becomes not only from a financial perspective, but it comes around your actual staff's physical safety.
Okay. I want to come back to Vuyo on the subject of we mentioned the state of disaster, and again, I don't want to put you on the spot on any particular initiatives, but I'm just interested to sort of explore the idea. So there's a state of disaster which has been declared to try and assist in the situation, and there are a lot of different views on whether this is a good or a bad thing. But maybe if we could just touch on the idea of a state of disaster and the talk of essential facilities. What is an essential facility? Who should be, who should be exempt from load shedding? Who should not in this industry?
Okay, thank you for that. I actually like when you start with your last part on exemption. So everyone wants to be exempted, right? Everyone.
Should be a politician.
That was the first call I had run. All my members know we want to be exempted. And first point of call, they send you this document called NRS. It has four things happening after it. Essentially, if you are an essential facility and you've been declared, you can be exempted. But it's not possible, right? Because even hospitals are not being exempted. Even now there's a court case on hospitals and schools that are required to be exempted because the law says they can be exempted, but it's not possible. So the state of national disaster, in a nutshell, it means this: as South Africa, we want to go back to the drawing board and say, and this is how it's supposed to work, and say, how do we resolve the issue of power? To the point that you made, Mark, earlier about investing in alternative power solutions without government interference. That is about certainty. I say government just have a certainty that will say, if somebody wants to come as a supplier, right, be it for own or for others, that is end users, give them certainty as to what things they will find in South Africa in terms of regulatory policy certainty. The issue of security comes top of mind. So when you look at the document from the Trade and Industry and Competition, it did not talk to security. So we inserted it, like, you cannot do anything with power without security. I like the comment that says, oh, at night, no, you must go to the Eastern Cape. Between Grahamstown and East London, those rural areas, the trees are stolen in broad daylight, right? Because it's mostly elderly people, right, that live in those areas. In broad day, they don't wait. At the moment there's load shedding, a bakkie comes, then they do their business. So you are supposed to reflect and say, this is noted on when it's state of national disaster. What is it that can be done? And government then says, bring your wish list, right? This we asked in January about the wish list. We wrote a long wish list. So for instance, basic things, if you think about quality of service obligations that you have, they say the people that you offer the service to, your network operators, they expect certain quality of service that is available throughout because government demands them of such. If not, they have to give end users a refund, right? Because it's not an act of nature. So like suspend those issues for now. We're saying release. I know other people might disagree with this. Like, yes, Spectrum was licensed last year. 5G was licensed. Yippee, yes, we're happy. But government put a condition that said, well, when you are building networks, start outside in. Outside in meaning start in rural areas. It's not practical, right? Because we know cities subsidize rural areas. That's just hold on there. And then they put other obligations that says, thou shalt connect X number of schools. This is a big debate that we've been having with government around connectivity of schools because we've been doing this since 1997 and it's not working. Correct? So we're saying we need you guys to go back to the drawing board and come up with a map because state of national disaster gives everyone the opportunity to go back and reflect and say, this law is not working. To the point of the stolen batteries, the second-hand good legislation, the Act, it is not working. The penalties that are there are not working. But now the point is because we've been through state of national disasters before, we want these solutions long-term, right? We don't want after the 2-year period, we go back to the normal way of doing things. If you've come up with a legislation to deal with the cross-border issues around batteries, let's keep that law in place because we want it to work, because we want effective prosecution of people that are involved in these crimes. We want results to be shown. The same with the issue of build. So I think you made it the point, Mark, that somebody requires you to say, come and build a network, right? And then we're going to give you these exemptions for a period of 24 months. But why should a person from wherever come, let's say the people from Ireland, I know now South Africa is an island trying to solicit people to come, the joint energy plan, to solicit investors to come into South Africa. Why would a person come here if after 2 years the rules may change, right? So we're saying even if the rules do change, give people certainty as to what they are coming for. No one will invest in energy for a period of 2 years. We'll be investing in energy for the next 10, 20 years, if that is how, depending what you're bringing on board. So those are the kind of things that we know is an opportunity for purposes of the national state of disaster. The differences, and I'm sorry I'll keep quoting some of my colleagues, the differences this time, which I think is making people pull their hair when we had the meeting that Juanita refers to yesterday, is the lack of urgency. Yeah. We see that people are not as fast as they were when we were the last state of national disaster. It is extremely, extremely slow, and there is nothing supporting what they are coming up with. And going back to the issue of saying, if you're saying it's a state of national disaster, there has to be urgency. And when there's urgency, we're expecting things to work in a certain way. So I think that has been a sort of disappointment for us. Hence, we're having our sessions on the side. There are people that are quite urgent. So the issue of bringing in the Minister of Electricity on board, because his role is more project management, and he's doing it. Like, you're supposed to, these are the activities that you're supposed to do. How far are you? Did you, instead of putting Band-Aid, put a cast on, right, in order to fix this? That is more of a great issue with ESCOM. However, we know that NICOM itself hasn't functioned in so many months, only started functioning towards the end of last year. We would like some light some fire into it so that changes happen as quickly as possible. I think I was actually before the state of national disaster, I was invited to this meeting with Juanita. We're told in 2 weeks, NERSA is going to publish the wheeling framework. How many weeks now?
Okay. I'm going to pick up on that wheeling framework because I want to hand that to Juanita. And maybe. No, that's great. So Juanita, let's get a bit technical for a bit. So for networks, it's quite challenging keeping the power on because a lot of it is distributed, battery backup, and as you heard, putting a solar panel up doesn't always work. There's a different challenge in the larger network hubs and data centers, and that is if you can obtain alternative sources of energy, you can kill two birds with one stone. You can at the same time be your own provider, or at least purchase your own energy at the same time as greening or moving towards renewable energy. And the good news is that the President actually announced this last year, more than a year ago, opened up the ability to self-generate on site. Unfortunately, most data centers are not big enough to self-generate enough of their own power. Physically, you need big space. But you can certainly purchase from an independent power producer, and you can certainly wheel. But, and this is the question to Juanita, to make that happen, that physical chain, what are the stumbling blocks and what needs to be fixed now?
It's so easy. It's just policy.
Okay.
It's really just as simple as policy. I mean, there's a lot of opportunities for data centers to already involve in wheeling agreements. And many of them have entered into agreements with metros, but the units inside of these metros, Eskom won't sign any agreements with them because they've got outstanding debt. So they say, settle your debt, and then
campus, which is a 90 megawatt facility. It's not an Equinix one. And it's fantastic. It's got really fabulous low PUE, green energy because they're sucking water out of the sea and pumping hot water back in. which is not really my idea of sustaining the planet, to be honest. It's getting back to that Google data center. That's not the answer. You know, just because it's saving the ozone layer doesn't mean that it's not damaging the planet. We've got to be more efficient generating the heat we generate, and then what we do with that heat as well.
Anybody else want to comment? I know we did have some WIAC OADC people present. I don't think anybody who can actually talk on it. Say that, I mean, there certainly is a trend. I mean, a lot of the, and it kind of goes hand in hand with 5G and the distributed nature of networks now as well, is that there is certainly a trend towards edge data centers, perhaps more so in some markets than others. And you know, we're seeing those start to happen, but I think I would tend to agree with Martin. Adding the edge doesn't remove the core. You know, you're still going to need these large data centers, and you know, a typical data center construction in South Africa today, you know, 10, 20, 30, 40 megawatt type deployments, you know, unless you're actually building, you know, a power station next door, there's no easy way that you're going to be able to be your own supplier. You're going to need remote sources, independent power producers to feed it. Sorry, Mark?
Yeah, I was just going to say that, I mean, the reality of renewables is that at scale, they're really temperamental. And data centers are massive scale, as many other large-scale industries are that require energy. So, I mean, it sounds nice and sounds good to say we're going to go green renewables, but unless it's hydro or nuclear, it doesn't make sense. I think trying to leave enough space for the large consumers like industry, you know, smelting, data center, etc., on the main grid, supplemented whatever else they can get, and move people away more to microgrids, which can scale with renewables because it's smaller demand, I think is the way to go. In trying to get a data center totally green, you know, without any grid reliance is, yeah, I don't think we have that much land for that sort of thing.
Yeah. I just wanted to say one more thing, and that is that in terms of, you know, I mean, vendor equipment, you know what's happened with vendor equipment. 15 kVA, 1730 kVA. I don't see any sign of any reduction in, you know, core. You've got an optical transport node and it needs at full tilt when in 5 years' time that's going to need 30 kVA. The data center, unless you build a data center that's very small and says, sorry, you know, we can only accommodate 10 customers, it's obvious that the power density requirement goes up. However, on the question of power generation, Equinix has been with 15 data centers in the US. They've been experimenting with solid oxide fuel cells as a first step towards hydrogen fuel cells, which will be, I guess, 100% green because all it produces water at the end. So there are, I mean, serious moves afoot to try and be self-sufficient in terms of power generation and doing so in as green fashion as is possible.
Yeah, I think that last point also is very interesting, is that technology might be the savior eventually as well. I mean, even for the base load that Mark was talking about, you know, solar's great in South Africa. You can do a lot of things with solar, just the sun doesn't shine at night. And so storage becomes a pretty fundamental problem, as well as stability of the grid, etc. Right, any other questions?
Anybody else? Back here.
Yep.
My name is Alex Mann from Man IT. I'd like to address this question to the gentleman from CCOM. When you started out, you mentioned that you'd planned for a total outage of Eskom. Could you unpack this for us, please, in terms of your network?
Well, we are reviewing what we can do, and we are sort of getting a sense for where we really can't do much. So, like the cable administration, again, is easy to fix because that's a diesel situation, which we're looking at augmenting with PV and battery, lithium-ion battery. So that's easy. The only other two places where we have significant network that could have national impact is, you know, from the East Coast into Johannesburg, down into Cape Town and Rand. And that also is another area that we'd like to harden. But the fundamental issue for us is the amplification sites along the route
hotspots for theft. And we don't own most of those locations, right? So we're working with the owners of those sites to see what we can do. I mean, there's 1 or 2 sites that we have that get broken into at least once every 6 months. It doesn't matter what we do. So that's the bigger issue on that, but we can potentially keep those lines up. We are majorly in the Terraco facilities. Metro, in all fairness, there's not much that we can do there because they're in commercial areas that don't really prioritize backup, and they prioritize rent space. So we've accepted that there's not much we can do there. It's not, nevertheless, I mean, that network is a third-party network anyway, so technically it would be the responsibility, so are the buildings. But even then, it's just so many thousands of buildings, you know, it doesn't make sense for us. So we're prioritizing the cable landing stations, the major national routes, and also staff at their homes. The weak link with staff at their homes is if the fiber provider has some kind of uptime in the local GPON metro as well. So, you know, and then that takes us back to mobile networks, which, as we know, when load shedding happens, the mobile networks die. So it's pretty dire, and we can keep the network up in those sections. How useful it will be in real life to customers, we really don't know yet.
Does anybody else have any Blackstock plans?
It is, as I mentioned, you know, fundamental to us to keep all our nodes alive. I know that we, CCOM will rely on the likes of the Link Africa, DFA, etc. as well to ensure that their networks are up. And as you mentioned, the endpoints. So it is incumbent on us to ensure that we keep our networks alive. But you know, there are certain places where you have to rely on the landlord and what they're doing from a backup perspective for the GPON systems that sit inside those areas that we don't have access to essentially or control over.
So, you know, just coming from the ADC perspective, you know, business continuity is one of those terribly boring things that people never, ever, ever want to spend time on. And I remember, we get the date right, it's about 3 years ago now, almost exactly 3 years ago now. I remember our operations team pulling out the business continuity plan and dusting off the annexure on pandemic. And we had one, we actually did. We had a business continuity plan for pandemic. It wasn't exactly what we expected, because it wasn't supposed to last 2 years. But we implemented it, you know, we really did. So my comment about the sort of worst case scenario is come down. Obviously we're thinking about that. Obviously we need a plan. So given that Mark trusts us, I don't want to tell you the whole detail, but the essence of it is this. Obviously we run on generators on diesel generators when there's no mains power. And at the moment, in terms of available diesel that we have either ourselves or stored by others or accessible to our sites, we have roughly a month of diesel for our entire set of data centers. So if the power goes off completely and there's no source of anything, we have about a month, which is much more than you'll find as a sort of normal perspective.
Anybody else in the audience?
Yeah, sorry, we keep going. I don't know what our timing is like.
We got till 4:30. On the agenda it says till 4:30. So.
Yeah, we got 4:30.
I mean, after that, it's the reception.
Yeah.
Hi, Graham from Various Hats. More of a comment than a question. I think on the point of disaster recovery plans, the sense I get, and I mean, we saw it in the pandemic, you alluded to it there, that whatever disaster plan we have is always the rose-tinted version of that particular class of disaster. So I see, and I mean, Mark and I, we've chatted on the chat groups about this as well, is that a lot of people are saying, okay, well, if Eskom loses power for 2 weeks, then this is what we'll do, and this is what we'll do, and you kind of say, okay, so your plan is to just
just fill up your diesel generator continuously and you'll be good. But have you figured out what's going to happen with the rioting in the streets that's stopping your diesel tankers from arriving? Or have you figured out all of these other scenarios? And I think that it's important to talk through these issues, and I think we do need to spend time preparing, and I think we are potentially being optimistic and maybe not like just staring in the face what the real worst case scenario could be, and realizing, as Marcus said, that we're not actually going to solve for it. We're not going to just potter along and carry on running, and we're going to sit at home and watch Netflix and chill the whole way through the disaster. It's going to be rough. But understanding where that point is, and then figuring out where on that spectrum, A, as a business, each of us can afford to be, B, how much we keep running. I was in a workshop last week on power backup equipment and power backup systems. And there was an interesting kind of exchange between a couple of us. And one of the guys who was an electrical kind of person, and we were talking about the capabilities to, within a single pop, shut down parts of your pop to save power. And his view was, well, my whole pop can stay up, I don't care. And I think that's another example of that kind of thing. And I don't know whether the data centers are considering this, but I would say there needs to be a little bit of consideration amongst the whole industry to say, when we've run out of capacity to keep the whole network alive, where are we going to focus? Which data halls are we going to load shed to make sure that other things keep running? Which pops are we going to abandon in certain suburbs because we just can't afford to keep them running because other things are more important to keeping the country moving forward?
Not that pop, no, just not that one.
Yeah. So Juanita's been applying her mind to this problem.
Graham, I wanted to just say to you, so first I just want to do an anecdotal thing. I actually just this week read, I think it's one of the big banks in one of the towers, you know, this guy said that on the 10th of September, his DR plan meant nothing to him. It sat on the shelf. On the 11th of September, that morning, 10 o'clock, that DR plan was everything. And I think out of all the banks that was in the Twin Towers, they lost the fewest people because they literally implemented their plan and they stuck to it. But I mean, we saw in the last couple of years, it's, you know, in KZN we had the floods. You know, it's like there's a lot of stuff that can go wrong. Nobody would have thought the pandemic. But just on that note, ourselves, and I know that ACT as well, are asking for competition, commission, relaxation for the sectors so that we can come together to more freely discuss how we can either pool or find solutions as a sector together. So you'll know that we're heavily governed by the Comcom. And, you know, they, like even, you know, we've got to like declare things, and normally when we have sector meetings, you've got to sign attendance registers and list who's there, and, you know, the people in the room have minutes of the meetings, all of these things that must be readily available. So, but several of the industry associations have asked for relaxation from the Comcom so that we can better discuss sort of DR plans, backup plans, how can we come together as a sector to support each other in the event of, you know, ongoing stage 8 or worse, complete blackout.
Good. Mark? Sorry, anybody else who wants to comment?
I think just to add to that plan, I think to echo what Graham is saying is that, you know, in the best of intentions, the best of cases, we hope everything will keep running. But, you know, if we do have a multi-week blackout, then yeah, we do have to prioritize because a shared resource is a shared resource, right? Not everybody can use the lift at the same time. So I think one of those considerations, you know, as competitors or as industry in general would be to suggest, you know, what do we allow to carry on the network, right? Do we just limit it to voice and SMS, or just SMS, right? No more data, no more WhatsApp, no more YouTube, that sort of thing. And I think that is a rather doomsday discussion, but I think it's worth having, because if we do find ourselves in that position, we do have to, you know, just as ESCOM is load shedding,
from this network. We do have to shed non-priority traffic so we can at least, keep people alive. So I think that's, an unfortunate discussion to have, but if you want to have a DR plan that is exhaustive and comprehensive, I think a couple of lines in there about that might not be unuseful.
Okay, I'm assuming there are no more questions. We are now running up against time, but what we're holding people up from drinks, so maybe we should close. What I'm going to suggest is just to go down the line, maybe sort of 1 minute each, just quickly on your take on the current situation, what you as an organisation are, how you as an organisation are approaching it, and if you think there's anything else we jointly should be doing it. We can get that into 1 minute. Martin.
Started with the guy who knows least about this.
Revolves around keeping network services running by providing, suitably predictable power sources. But hopefully, there'll be a bigger conversation later on about sustainability. And I'm always mindful that I find it strange that ESG talks about power and greening the planet, but then also talks about diversity and respect and ethics and stuff that are critically important to some of this stuff that we're talking about here. And so I'm sure there's a part for, for us to play in that.
Yeah, I think on a personal level, I think in your home, in your family, I'd say, put the 2-year Paris holiday money aside and get some energy invested. You can go for that trip in 2 or 3 years once it's sorted. And then I think at the broader scale, I think just to get policy to just give people more freedom to experiment. Just release people to experiment and come up with what they think works for them. Good.
Yes, actually for me, and I've actually mentioned before, at the end of it, most of the solutions reside within us as both as industry players and as end users, because government itself does not know what is it that needs to be done in actual effect. The key part, I would say, for the short resilience, I say South Africans are hopeful, they're very hopeful people, it's a good thing to have, but within that hope, we have to have to action, and that is what I strive for, that we prepare respectfully to ensure that government does what I'm going and doing on the street, to make sure that government does what it's required to be doing, easing the regulatory burden on people, and also making sure that the policies that they put in place makes sense.
Thank you. So I think I mentioned a lot of it during my last comment. It's the circle that I spoke of where we have to, fixing one thing isn't going to fix it all. We have to fix the multitude of problems, which is the austerity, the power, and keeping our costs
workable for profitability and the ability for us to deliver into more rural areas. It's been a very interesting talk. I appreciate the panel. There's some discussions I'd like to have afterwards with some of you around certain forums that we're trying to start that I see have already been started, that how we can link in with you. And I think that this is, if we just use the word community, we are a community that all has to stick together and essentially make this work. We don't have any other options. A lot of us are parents raising kids in this country. We have to make it work. And, as Link Africa, we are committed to making it work. Thank you.
Yeah, thanks. From my side, I see opportunity in every crisis. It's the right approach to turn the crisis into opportunities is what's key, and for me it's about collaboration between suppliers and customers, and we all each other's customers in one or other form, whether it's as business or in our private capacity. So it's really, and that's how we've always approached it, how we ask our customers how they would like us to help them solve problems, and we turn that question, and they turn that question around to us. So, and our market participants as well, as Anita was alluding to. So I think I look forward to doing more of that.
Thanks for hanging around to listen to us. I think more forums like this is always helpful, having conversations, sharing ideas, coming together, and like Mark was saying, carrying each other through this. There's a lot of initiatives, if you look at or you reach out to some of the industry associations. For instance, we signed an MOU with CISP, the Cloud Infrastructure Service Providers of Europe. We'd like to do a code of conduct for South Africa and develop it based on the CISP code of conduct and look at more self-regulation of the sector as opposed to hardcore regulation. But yeah, if you want to know, speak to Buyo and myself. There's a lot of work that is happening behind the scenes. And yeah, thanks to all of you guys that are members of our associations and help us walk the passages. It's been absolutely phenomenal, and I can only say a privilege to watch the sectors grow over the last 13, 14 years, and from sectors that never even existed to companies that are employing tens of thousands of people. So it's really fantastic, and keep up the good work, everyone. Thanks, Dr. A.
Right, just from my side, I mean, as Africa Data Centers, I think we certainly appreciate the opportunity to collaborate within the larger industry. I think never waste a good crisis. What we've certainly found in the last couple of months, as load shedding has got worse, and suddenly the state of disaster and everybody's starting to talk to each other, we've had significantly more interaction and effective steps taken just in the last couple of months than in years before. And with my other hat on, as a member of the Inks Committee for Inks ZA, I think just the fact that we as a community can get together and solve a lot of our own problems and not assume someone else is going to do it for us, it's been great. It just remains for me to thank all the panel members. Thank you very much for having participated. I know it looked like a large and intimidating panel when we started, but we made particular effort to try and get a diversity of views, diversity of different players in the industry, and particularly people who've had a lot to do with trying to deal with the issue over the last couple of months. So thank you, and thank you to all of you.
All right, folks. Thank you again to our panel for some very insightful information on power and energy here in South Africa. Well, that wraps up today, and all we have left now is the reception over in the courtyard area in just a couple of minutes. But before we go, just a couple of quick housekeeping things. A reminder, tomorrow we have several good workshops going. We have Ricardo's operational security and OPSEC trainings going on, and we also have the RPKI training. So strongly encourage you to sign up and attend to those events. We've got some good material there and so forth. I'd like to thank our sponsors, Flex Optics, Inks, Netflix, Afrinet, Equinix, Terraco, Africa Data Centers, Open Access Data Centers, Clear Access, Duxbury Networking, Agile, Work Online, Splace, and Link Africa for helping make ZANOG what it is today and having these 2 great days plus the training tomorrow. And also a thanks to our speakers and presenters. thank you very much for coming out, putting the effort and energy in, and producing a great set of materials. And we have speaker gifts, I'm now told. If you were a primary speaker, please come on up so that we can get you your speaker gift. Hey Ed, if you could get Jared from outside, that would probably be good. And I also want to thank the ZANOG program committee for putting together a great program here. So we'll wait for a second for the speaker gifts to arrive, and then if you are a speaker, please come on up.
I'm not going to that.
All right, if you're a speaker, come on up. Mark, thank you very much. I learned a lot about undersea cable stuff today. Thank you. Ricardo, always good to see you. Martin, thank you. You. Mr. Madison. Bill. Of course he is. Ricardo, do you know Jared March? Yeah, if he's outside, have him so he doesn't get lost. Thank you. Anybody else that was a primary speaker? Yeah? What about the lightning? Jared, thank you for coming all the way from Michigan.
Yeah.
Right on up here, sir.
Uh-oh. You need a gift.
Front and center stage. I trust you, it's not ticking. But it's sweet.
Thank you for having me.
All right, Ed, anything else? Is that a wrap?
Oh, no.
Wait. A group photo. All right, well, I mean, you all need to squish in. I've done this before. Oh, a photo of Jared getting his present. Okay. You got to take it back. Dun, dun, dun. That was a nice curtsy.
Excellent.
Did you?
Well, we did the same. We had to restate
I spoke.
photos
Okay.
of my wedding too.
Danke. I did speak. I spaked. Are we wrapped?
Group photo.
Group photo.
Group
Front or on?
Group photo.
Up, where?
Here.
Up front, maybe?
Abby.
Or right out here under the logo?
Like front side.
Okay. Photographer says group photo outside. All right. Other than that, thank you all very much for being here. And then we have the alcohol will be in the courtyard. I mean, the reception will be in the courtyard. All right? Thank you so much, folks. Have a great day. Test. Whose Macintosh is up here on the podium? I have a lost Apple Macintosh laptop.